Hello, test mic, 1 2 3. 1 2 3, test mic. Test 1 2 3.
Loud and clear, Engineer Russ.
Okay, thank you very much. Just cross check. Okay, we will start now for our PM session. Okay, so before I commence the afternoon session, I would like to share a quote about knowledge. Knowledge is like money. To be valued, it must circulate. And circulating it, it can increase quantity and hopefully in value. This is from Luis Alamor. My fellow electronic professionals, IECEP student chapters, to our technical speakers, good afternoon, Philippines. Good morning, Middle East, as well as good day to every one of you throughout the world. The organizing team will feature excellent speaker on this afternoon session. 3 speakers, by the way. They will share their technical knowledge and expertise with us. We're very lucky to be on this colloquium. And I have no doubt that we will learn quantity, okay, from these speakers. I would like to ask our virtual audience, by the way, to press the letter Y on your keyboard if you are ready for this afternoon session. Thank you. So I learned a lot of it. So, wait a minute. Okay, because there's a vibration. So this colloquium is hosted by Power Electronics Society in collaboration with the Bulacan chapter. Yes, thank you. Yes. We're ready to go. Bulacan chapter, ERC chapter, Manila, Mindoro, and IECEP school chapters, Adamson and Cavite. Okay, everybody say yes. So let's ready to rumble. By the way, I am Engineer Russell Torres of IECEP KSA-ERC here in Saudi Arabia as your master of ceremony for this afternoon webinar. Okay, now let's go for the house rule. Zoom master, please zoom in our house rule to remind everybody for our house rule. House rule, if you can see, it's very clear, same this morning. So please do so. Okay, next, we will go for our qualification for our e-certificate. How you be qualified? It is in your window. So please review it once more time to be qualified for the e-certificate. Remember, I think you have to complete the session, sign the attendance form, pass the evaluation test, accomplish the survey, by the way. Okay, now let's go to our webinar proper for topic number 3. Without further ado, I will begin the third topic of the colloquium, and I would like to call Engineer Tufilo Bitoon, the VP External of IECEP KSA, for the introduction of the resource speaker. Engineer Bitoon, the e-space is yours.
Thank you, Engineer Russ. Good morning, KSA. Good afternoon, Philippines. Good day, everyone. I am now presenting to you our next speaker, and a brief introduction about herself. She graduated from the University of the Philippines with a Bachelor of Science in Electronics and Communications Engineering, and took her Masters of Science in Electrical Engineering in the same university. And she has a very wide experience in this field, in the field of power electronics. She started as officer in charge, then became an assistant professor, then she became a design engineer, then a senior research and development engineer, a team supervisor, a design engineering manager, and lately, she is the senior manager of advanced engineering company. Then, to give some highlights of her awards, I could say it's huge. So, she was a consistent scholar at the University of the Philippines, Transport Training Center, and also at Avon President's Club Scholarship. She was a full scholar of DOST. And when she graduated her degree, she was a cum laude. And she was also a magna cum laude in her master's degree. Not only that, she was top number 18 in a board exam. Then she has a title as she get the title as an exchange scientist in Japan Society for the Promotion of Science General Exchange Program. Then she got the distinctive merit. Renaissance H8 microcontroller design contest, and she was granted the patent number grant 1127025 and redundant DC input power supplies having backfeed protection. And let me mention also of her published conference papers, namely switching performance characterization of SIC Schottky diodes in switch mode DC to DC converters, DSP-based switch mode audio power amplifier, and there's variable high voltage DC switch mode power supply. Then lastly, the digital control of a variable DC switch mode power supply using an embedded microcontroller. So I could say she has a very huge achievements. She must have done things very extraordinarily. So without further ado, please join me in welcoming with her topic, advancement and recent trends in power conversion. Please welcome Engineer Roshi Ligaya S. Libby.
Thank you. Thank you very much, Engineer Bituan. Is my audio very clear?
Yes.
Yes,
Okay,
loud
thank
and
you very
clear.
much. Good afternoon, everybody. Certainly, this is I can say it's a pool of talented engineers in the Philippines. So I'm happy to be here and to share a little bit of what we do in our company and the kind of trends we are seeing in power conversion. So let me just share my screen. Share. Are you able to see it?
Yes, clear. Go ahead.
All right. So this is an hour and a half, right? Including the Q&A. So I have a bunch of slides, but it's actually split into two key, I would say, key topics. Number one is definitely the trends in power conversion, and I'd go into that first so that I won't bore you with the company presentation side of it. But the company presentation really is more of introducing us as a new member, right, of IECEP, and for you to know what we do in our design center, because we are a design center of excellence here in the Philippines. So jumping into it, yes, power electronics is a very broad, I would say, field, and it's also multidisciplinary. And this is really just a subset of what power electronics is. It could be motor drives, it could be digital control of power conversion. But then at the heart of it, you have AC to DC conversion or DC to DC conversion, or even inverter converting it to AC. And the key driver really is number one, the kind of conversion efficiency, it's getting very aggressive. The power density, basically, it's not just about shrinking it, but, about defining the form factor, but really, more importantly, how you manage the thermals when you shrink the electronics, the power electronics, big way. And definitely there's the scalability into it, how you can scale it up to different or higher power levels. And the enablers to that are for sure the advancement in device technology, in your semiconductors, as well as your magnetics. It could be in magnetics, it could be core materials. And just an example of, or a few examples of the markets that we serve: computing and storage, industrial and medical applications, telecoms, I would say networking. It could also be even on the bigger advanced energy organization. We also have plasma power generation. So, and we also have up to critical sensing and high voltage supplies. So when you look at technology drivers, on the one hand, you need to have performance, which is, we're talking about conversion efficiency, density, and then the kind of thermal management you put in there, and the topologies you select. I'll discuss more about the topologies later on. And of course, overall, you have to look at the cost, whether it's the cost, whether it's your cost of devices that you're using, or the cost of developing one. And therefore, that comes into mind how you automate your, let's say if you're into design and manufacturing, how automation can be driven, and definitely a reuse of your design. And the other part of it would be, what kind of value add do you offer? So are you able to communicate seamlessly to the system, to the host system, or can you provide telemetry or some predictive failure analysis? And also definitely one of the very crucial part of it is digital control when you have embedded systems, embedded power. So here's an example of some of the product lines we have, spanning from, I would say, this is at least 24 kilowatt. You'd say it's a configurable output. This is also configurable. This is a couple of 2 kilowatt up to 2 kilowatt power, and all the way down to as small as I would say a pin, and board mount power. So I'm just highlighting a couple of areas where it's very competitive. So if you've heard of open compute, so people like the industry tech leaders, really people like Facebook, Google, they're into this. This is collaboration among the industry tech leaders and I would say the hardware technology side. If there's open source, there's also the hardware equivalent to that, which is open compute, and it actually defines very aggressive efficiencies. I'm talking about all the way from your AC inlet to your output DC, overall 97.5% peak, going 98% peak. So you would imagine throwing away only 2% dissipation. So if you have say a kilowatt of power that you're processing, you're only able to throw away what's 2% of 1 kilo? It's 20 watts. Is it? Yeah. So that is very important, because as you process higher and higher power, you're talking about tens of kilowatts, then managing the thermals, what you're throwing away, the amount of heat inside is very, very challenging. So you'll also have to definitely ensure that your conversion efficiency is very high. And of course, definitely there's a push for green energy, higher efficiency, standby power in some cases. Those are all considered in the equation. So the other aspect, let's say for industrial power, once you go into higher power conversion, you will be limited, let's say, if you're taking it from single phase. So if you have a 30 amp breaker, probably you can extract as much as, I would say, 5 kilowatts out of it for your from your single phase high line. And so the moment you go into very high power processing, definitely you're bringing your 3-phase power now into the power supply module. And therefore there is, of course, an increase in complexity when you do that, but it allows you to increase the power. We also have to keep in mind how you can configure it, how you can make it a flexible design. And in terms of cooling techniques, it's not just fan cooled. It could be board mounted, or it could be even immersion, where you really dunk your power supply into a tub of dielectric coolant. Right. So those are just some examples. And this is an example of, I don't know if you can see my mouse. I'm using it as a pointer, actually. You can see down at the lower right-hand corner, this is a redundant input. So you can see 2 plugs shown there. A redundant input power supply, one of the designs we did before. So it's kind of like ATS, automatic transfer switch, but so it's a subset of that. But it's following that kind of principle where you have, once you have loss of AC, then you have to have a seamless takeover from the other feed. That can also be in DC, high voltage DC. Let's say you feed 400 volts redundant input. And as I've mentioned, drive for a high efficiency enabled by device technologies such as wide bandgap devices, silicon carbide and gallium nitride. And then the magnetics design of it, they have to make sure how you're able to extract the most out of the magnetics design. So that could mean integration. That could also mean your winding structure has to be for optimum or for minimizing the AC resistances, because you're actually dealing with high frequency switching and therefore high frequency content. So it's no longer just copper content or DC resistance, but also your AC resistance. And therefore, once you go into that kind of scenario, you have to be mindful of the EMI. Now, in terms of power densities, what we're looking at really is greater than 60 watts per cubic inch for 1U. When you say 1U profile, this common profile for power supply modules, which is like 40 mm height. That's a 1U height. For 3-phase power, it's slightly lower density because once you go into 3-phase, directly into 3-phase power, feeding it directly into the power supply module, you're going to deal with higher voltages and therefore larger spacing. And then for board mount power, like the ones I've shown in the previous slide, that can be like 800 watts per cubic inch or even more. So there's a huge amount of, say, technology, cross-disciplinary, multidisciplinary technologies involved when you come up with a power supply or power conversion system. So some of the even solutions that we have are into the controls of it, how it will respond to transient loading conditions, and how to ensure stability. And then some tricks. That's a nice thing with having a digital controlled power supply. You can have lots of tricks up your sleeve because you're no longer basically constrained by the analog control. So you can have nonlinear control techniques that you can apply. Now, I'm talking about power supply, but really at the broader sense, if you look at the system, like in a system, let me just move my, let me interrupt myself, move. All right. At the broader sense, you have, you really have let's say in a system where you have a mix of AC and DC power, there has to be synergy. It has to be an interplay of AC and DC power, but this is one scenario where you have a DC bus, but then you can look at the flow of the arrows really is a flow of power. So this is actually showing you a bidirectional flow of power. So you have your EV here. You can actually feed into the DC bus, or some renewables feeding into the DC bus, and or you simply have an AC load. So you have an inverter coming from a DC bus. So the considerations here are the power flow, definitely bidirectional. Allowing bidirectional power flow is key. Providing galvanic isolation is important, and of course, fault protection. And again, how you can increase the power density or reduce the weight and size and still maintain the performance that you need. Now, I'm going to go into EV fast charging, but before that, I'm showing you some numbers from BNEF. It's Bloomberg. It's New Energy Finance. If you've come across it, it's really they're into the they're into cutting edge research for market trends. So they're spanning, I would say, 6 continents. They're looking at research that's involved in minimizing carbon footprint, basically. So part of that is EV and EV fast charging. So before that, you can see these figures. These are very recent figures. The amount of, so this is global, the amount of utilization, right? If you look at it in terms of the type, say trucks, passenger cars, buses, and our motorbikes and trikes and 3-wheelers. So this is already about half of it. So I would say the opportunities really lie on passenger cars, which is because this is just like globally 14%, but all the more the high-end ones, I'd say the high-end trucks, vans, and then even the buses are still, I'd say in terms of market share that's available, there's still huge market share and opportunity. If you look at in terms of EV sales by market globally, China is still leading it. See red as that's China, green probably, or teal is probably like Europe, right? And then US is coming up. And then if you look at, let's say, just lithium-ion battery demand by application, still majority is in passenger EV. So there's really a pressure on the demand. And recently I came across an article saying that we are, surprise, surprise, we are the second largest nickel exporter. So there's a huge amount of opportunity for the Philippines. Really, there's a drive for EV charging. Now, when you look at EVSE, or the vehicle supply equipment, it's really broadly categorized into 3 levels. So it's levels 1, 2, 3, and really roughly into the amount of charging power that's available and how fast you can charge. And of course, it's assuming what kind of acceptance rate for the battery. But roughly level 1, you'll see slightly different numbers if you look at different articles. But roughly level 1 is drawn from single phase, 12 to 16 amps, and quite a long time to charge, right? So let's say a 24 kilowatt hour capacity battery will be charged in 17 hours. So this is really meant for home use, overnight kind of charging. So not very efficient. Level 2 is slightly higher. You would probably see this more so this is still 208 polyphase, probably in malls and offices kind of setting, when you're probably parked, which is the case. I'll probably mention that later on. Most of the vehicles are parked for a long time. So this one is kind of filling in that market, but where it's very demanding really is the DC fast charging. Right, so this is, we call this level 3, and we're talking about range 300 to 920 volts and maximum 500 amps. So this is like charging 10 to 30 minutes And typically from 120, 150 kilowatts up to 350 kilowatts. So I've seen numbers something like for a 150 kilowatt charger, you can probably charge for your range, let's say 200 kilometers. So likely from, let's say, Baguio to maybe Vegan. That will take you about to charge. If I'm not mistaken, that will take you about 20 minutes for that kind of power. And then if you bump it up to 350 kilowatts, that's probably in the low order of less than 10 minutes charging. So that's the kind of power, if available, that we want to get into, because really, when you look at it, if you're going to replace, filling up your gasoline tank, then you wouldn't want to wait for a long time. So you just probably can accept that still the same amount of minutes spent when you top up your gasoline tank. So that's very important, versus the kilometers you can drive the car. So those are some of the considerations. There is even what they call a range anxiety for EV owners. So for plug-in hybrid EVs, it's really roughly categorized in terms of power level. If it's on board, those are the low power end, right? Maybe up to level 2 charging. But then beyond 20 kilowatts, I'd say 20 kilowatts all the way up, that needs to be off board, meaning to say it's no longer inside your vehicle, it should be outside. And once it's outside, basically your charging infrastructure directly interfaces to your battery management system. Now, before I get into deep on the topologies, really I've already mentioned a couple of considerations where you have number one, the amount of power you process for you to charge, and then the levels. So I would say that's one area. The other is in terms of your topology, it could be front end, which is the one that's coming from your distribution system. So whether it's single phase AC or 3-phase AC, and then the other end, which is the other half of it, is the DC-DC. That's the one that direct transfers the power to your batteries. So for the front end, since it's coming from AC, you need to have power factor correction. So one of the topologies very popular currently is totem pole, and it's because if you're familiar with power factor correction, you do have typically a front end boost. You want to have active power factor correction, where you want basically to line up your input. You process your switching such that your AC input current lines up with your input voltage. And ideally, that's very high unity power factor, right? If they're aligned, so it looks like resistive as far as the grid is concerned. So but that one typically has older technology. Is you do have a front end bridge to rectify, bridge as in bridge diode configuration, and that's very lossy actually prior to having your boost conversion. So getting rid of the front end diodes, that will really bring up your efficiency. That's because you imagine, remember, overall efficiency 97.5. So you only have 2.5% to throw away. So you really have to budget it. Maybe 0.5% goes to your devices, another maybe 0.8% to your magnetics, and then your bus bars and all those. So making sure you have the right topology is important. So this is an example, totem pole PFC. You have low frequency switches that actually takes care of the low frequency rectification. But then since you have MOSFETs instead of diode drops, so diode drop times your average current, that's automatically your loss. So that can be pretty huge. Just imagine you have average current 20 amps into your rectifier diode times 0.7, 0.8 drop. That's like 16 watts per device. So you don't like that. Now on the other hand, if you have low RDS and MOSFETs, then you're talking about 50 milliohm, sub 50 milliohm into your I squared RMS current. So that takes a huge amount of front end dissipation, right? So and then on the other hand, you have your high frequency switches. This is really where your switch mode is, and this one, because it's I'd say it's hard switching. You're transitioning, you're basically commutating hard switch, then you need to have the right devices for this one. And that's where they enter the wide bandgap devices, silicon carbide and gallium nitride, because they have, very low switching losses. And therefore you're able to switch them very fast because you're not limited by switching losses. So once you go to higher power, let's say for level 2, for instance, you can still use your maybe interleave totem pole. So there are two things here. It manages the ripple when you interleave because there's some amount of cancellation that happens. And then, of course, you're increasing your power. Other topologies, example for the front end still, but then the level 1, level 2 would be neutral point clamped PFC. It's multi-level, and therefore the voltage stress across the FETs are lower. Now, on the other half of it, if it's level 3, high power, then your front end becomes 3-phase typically. So you can have, coming from your 3-phase input, you can have, I'd say 6-switch boost type, very simple. But then the drawbacks here is that the switch actually sees the entire output voltage. So if your output voltage is 800 volts, then once the switch is off, so these are complementary, definitely. So this is on, this is off. So your voltage drop across the switch will be the entire output, which is 800 volts. So then you need to use higher voltage devices, at least 1200 volts for this, if you account for the spikes at switching, because this is hard switch. Now, of course, this is poor EMI simply because your DVDTs are higher. I mean, you see the entire 800 volts, right? On the other hand, there's also another popular 3-phase front end power factor correction, which is the Vienna type, Vienna rectifier, Vienna PFC. Here, what you're seeing really is just because your output now is plus minus, let's say plus minus 400 volts with a midpoint. Then coming from the midpoint to where you're commutating here, it's really just 400 volts stress. So when the FET is off, so in other words, you can use lower voltage rated devices like 650 volts devices, for instance. So that's the benefit of having a T-type level 3 kind of conversion. Also with neutral point clamp converter, again, lower voltage stresses on the FET. The one thing you need to note is if the configuration is like this, the power flow is unidirectional. So it's from the line, it's from the line to the load. But then you can consider bidirectional power flow if the rectifiers are actually converted into MOSFET switches. So, but then of course, there's a level of complexity associated with that. So that's for the front end. But then once you go DC-DC conversion, so we're talking about DC-DC topologies such as dual active bridge. As you can see, for the dual active bridge, basically you have primary side switches, primary side bridge, and then secondary side bridge. And the phase shift between these two bridges actually dictate the power flow. So whoever is leading is power flow will be from the leading to lagging. So and then you can reverse that phase shift and you can deliver power in the opposite direction. So that's where you get the bidirectionality. And so for the most part, it is ZVS. So ZVS is zero voltage switching, meaning to say you turn on your switch, you turn on your MOSFET once the voltage across its drain to source is 0. So you need to discharge its output capacitance first before you turn it on. Otherwise, you'll have all those turn on losses piling up when you turn it off with some amount of voltage still, or when you do it like hard switch kind of transition. Now, if it were just unidirectional, LLC is among the, I would say, high performance converter, unidirectional from input to output. And this is soft switching. So basically, you can achieve maximum performance, maximum efficiency if you're operating at resonant frequency of your LLC tank, right? So it can have both ZVS and ZCS is the other end, the zero current switching, meaning you turn on you turn off when your current is close to 0. So that's zero current switching. Because it's soft switching, the EMI performance is assumed to be, of course, better compared to hard switch technology. Now, this is unidirectional, but once you change these switches, this rectifier diodes at the secondary side to also active MOSFETs, and you have some form of control, and then you do, instead of an LLC, you make it a CLLC. There's some symmetry required there. Then you can have power flow in both ways. So these are examples of, I would say, high power, maybe level 3 type of power conversion on the DC-DC part. So overall, once you look at power topology considerations, then for your, let's say, EV fast charging, typically you have a front end coming from your 3-phase because it's high power charging. And then you do have your DC-DC conversion at the back end. Right. So all of that, of course, the assumption is you need to be able to control the power flow, one, whether unidirectional or bidirectional, and then the efficiency and power density, and then definitely the control complexity and the kind of devices you use here. So it could be silicon MOSFETs, the conventional silicon MOSFETs, but those will be very lossy with the reverse recovery of your body diode. And therefore, that's where wide bandgap devices come in. Now, when you look at wide bandgap devices or devices in general, you can also consider, you have to consider how you can cool them. So the packages, it can look like this. They're actually called modules, power modules, but they're more like the bulky, I would say, bulky packaged modules, but allowing to dissipate a lot more power per device. And these are like, I would say, encapsulated in aluminum nitride for thermal conduction. Quite common in, I would say, automotive, but it can also be discrete like this. So, and then when you say discrete devices, it can be surface mount, it can be through hole or surface mount devices. And also because you have to consider the cooling technique, right? It could be fan cooled or forced air cooling, but also it can be conduction. So you conduct to a cold plate, or it can be, as I've said, immersion, as in you immerse it in a dielectric coolant. Now, part of this, part of the consideration also is really because of the complexity of the controls, you have to be able to choose your DSPs, your digital signal processor. It has to be capable of the required number of peripherals, because if you're dealing with 3-phase, for example, then you have like, you're sensing 3 times, 3 different voltages, 3 different currents, and then you're also sensing your output, right? So the required peripherals should be considered. And then of course the processing power. So there are different control techniques for 3-phase power conversion. and that can be very involved. And you really have to consider if your device is capable or not. So the upcoming trends in EV fast charging. So I'd say there are a couple of key points here. Really, what you have is, let's say if you have an electric vehicle, ideally, if the technology is already there, then, and if you can make it very compact, a portable charger, but then you're not restricted as compared to your onboard charger, because it's not in the vehicle, then that would be ideal, because this can be paired together with your vehicle, right? But then you get as much charging power that you need, but then portable enough. So then that's where among the technologies, it's where part of the considerations where, okay, maybe if it's portable and it's paired with your EV, it's an attractive option. So also the other advantage to that is that because it's not on board the vehicle, so it's not required to go through automotive application stress test. So it's a different consideration if it's automotive grade, right? When your devices are automotive grade. The other consideration is, as I've said, because most of the cars or vehicles or even trucks or what, those are basically like parked most of the time. So say if you're driving a car, you go to office, you leave it like 8 hours, you work for 8 hours, maybe 12 hours, then your car is just parked. So there's available energy everywhere, right? So, but before we go there, actually, if you kind of think of it, if everybody goes, remember the pie chart that I've shown, it's just like 14%, right, globally. But you imagine, let's say if it increases to 50%, the kind of strain it will have on the distribution system. So you might have very, very huge peak demands, but then, and then we don't like rotating brownouts, right? So then there has to be a way to address that. And logically, yes, if the vehicles are parked most of the time, then if I would say the total amount of energy available in your battery, that can be harnessed to just supply the intermittencies in the grid. So that's why that can be a trend. The bidirectional power flow can be a trend, because the underlying problem is, imagine if people are charging at the same time and there's lots of them, so it will be a strain on the distribution system. So again, this will boil down to, because these are, I would say, very high performance, high power kind of designs, then it will boil down to the power topology that you use, the target power definitely, and then yes, performance indicators like efficiency and power density, and then the kind of high power charging, for example, 3-phase power factor correction, and then your DC-DC stages, multi-level form. If you go higher power, there's a tendency to go multi-level because you want to, one is you want to process, I would say, less DVDT stresses on the MOSFETs, and then there are different advantages to multi-level topologies as well. But then the trade-off is complexity, because you end up with more devices. So for the level 1, level 2 charging, then it's commonly, I would say, front end would be from a single phase AC, totem pole PFC, followed by a high efficiency LLC for low power end, and then the new requirements such as vehicle to grid calls for bidirectional power flow. And then and when you say bidirectional power flow, your front end has to be bidirectional, as well as your DC-DC has to be bidirectional. Right, and once you have your topology choice, then you have to examine the kind of technologies that complement them. So the semiconductor technology, the technology on the magnetics, materials, even cooling techniques and materials as well. Right. So overall, because we really design, we're a design and manufacturing, I'd say, company. So we have a design center here in Eastwood. It's in Eastwood. So it's really a design center of excellence. So we come up with ground up designs for our power converters, and we have to make sure that these are very competitive and really leading edge, I would say. So which means to say that you need to be very, very, I would say, sure-footed about your design, and therefore modeling and simulation is key to that. Understanding the topology and the operation and how you can maximize the performance are really key to that. So of course there are tools that can aid you. It can be by default, of course, there's circuit simulation tools, calculation tools like MathCAD, for example. And then you go into the magnetic side of things. You have your ANSYS Maxwell 3D simulation. This is an example of just a visual representation of how your flux density changes with your excitation in your coil. Beyond that, you can visualize your current density distribution, for example, in your bus bars, if you're carrying hundreds of amps of current. And then because we're operating at high switching frequencies, the parasitics are very important to minimize. Therefore, even your PCB critical loops for your switching have to be very, very tight. So there's a way to look to examine the kind of parasitic inductance and resistances you have in your critical loops in your PCB. And also, as I've said, since it's high density, you're packaging them very closely. This is an example. Then you need to make sure that you can thermally manage, right? So if it were, let's say, air cooled, then you can visualize your airflow, your fluid dynamics using FlowTherm. And then at the same time, since let's say if you're the electrical engineer or the electronics engineer, you design your power semiconductor devices, your magnetics, and then you come up with losses for each of those. So with each of those devices, there's an associated watts losses. And that together with your airflow situation and your, I say, ambient temperature assumptions in your simulation, the FlowTherm can give you a snapshot of the temperatures on your devices. Then you'd know if something is boiling hot, it's going to go thermal runaway in an actual scenario. So you know what thermal runaway is, right? Once that happens, then you can expect devices to, devices to explode or burn, right? So that's very important when you design. I'm sure in your experience handling power electronics, you see how much that is part, how electronics cooling is also part of the equation. So even beyond that, once you get very deep into the kind of technology you're developing, there are other tools that allow you to, of course, co-simulate. So you would say, I want to see, okay, how the flux moves in this core, but then I also want to trigger it with this kind of excitation. So it's a mix of electrical simulation as well as magnetics. So I can also plot my copper losses and my AC resistances per layer if I have a certain kind of structure in my winding. And then on the other hand, you can also do like what if I have new topology that I'm designing or I'm coming up, but then I want to understand how I can control it better. So this is my electrical simulation, and then this is my controller. So inside of this, it can be control block sets, and then it can be C scripts. So you can basically just co-simulate your control code and look at how the electronics respond to it. So you get all your waveforms, right? So this is what I'm referring to as being sure-footed in your design. and making sure that we know where to optimize and make sure that overall, if you look at it as a systems point of view, when you design a power conversion, it's really a system by itself. Then these are all considered. Right, so actually this ends my first half of the talk. I'm not sure if I'm going too fast or just right, or maybe lagging a little bit, but I'm going to the second part of the discussion. Basically who we are, Advanced Energy. So Advanced Energy is it's a publicly traded company in the US. It actually specializes on, I would say, precision power, cutting edge technologies on power conversion. We're talking different applications, a host of different applications. You'll see more of that in the later slides. But then the design center we have here actually evolved from, it started as Aztec, Aztec Custom Power before, and then it was acquired by Emerson, became Artisan, and then we merged with Advanced Energy. And we are now, as an entity, we're now Advanced Energy globally. So Advanced Energy is, it's headquartered in Denver, Colorado, and it's basically a pure play power leader, because the kind of aggressive power processing required, high slew rate output, it's more for the plasma power generation. That's part of the business of Advanced Energy. So I'd say it had record revenue in 2022 of $1.85 billion. So different market applications, you see it, whether it's semiconductor equipment, industrial power, medical, data center, hyperscale infrastructure, and telecoms and networking. So this is just a bit of history on who we are, particularly pertaining to the site here in the Philippines. So it was established 1995. It was Aztec at that time, and then basically became advanced. There's advanced engineering, which is so I'm heading advanced engineering in Eastwood. So the first advanced engineering was established in 1998, and then I would say we eventually. So we have other sites, definitely, like Hong Kong site. We also have, you'll see in the other slides later on, that we have sites in the US, in Europe, as well as rest of Asia. So we eventually became Emerson Network Power, and then became Artisan Embedded Technologies, and then merged with Advanced Energy. So this is what we do, a host of different products, right? And it enables our customers to do this. So it could be medical application, it could be data center, it could be also in transport. And so that you can also do this, basically. You can check your Facebook account. You can also plant your, whatever you want to plant indoors. So this is, indoor farming is big. It's a part of the horticultural applications, and definitely medical. And then this is telecoms, actually. So broadly, this is Advanced Energy. Our markets span semiconductor equipment and then custom power, right? Custom power for industrial and medical, and then data center computing, data center and computing. So where we come up with those high performance modules as well. And then definitely telecoms and networking. So these are the different markets. And say semiconductor equipment, they're really talking about etching, deposition, ion implantation. So those are thin film. So those are the aggressive markets served under semiconductor equipment. And then data center computing. So this is where we are familiar here in Eastwood. We're really talking about customers like, Facebook, Google, and maybe Amazon. Yeah. So these are these are part of our customers. And then industrial and medical. So industrial, which is sub of that would be, horticultural. And then you have your medical applications as well. And then of course, definitely your power supply, their telecoms equipment. So just a say an infographics of the kind of products and then market. So I would probably highlight one which I'm familiar with. Let's say, yeah, ATM cash machines. We developed one before. So you imagine if you have an ATM machine, you're trying to withdraw money, and then suddenly you get power outage. you lost the AC is there's brownout basically. So you're in the middle of withdrawing money. So what would happen? Card may be if there's no backup power, card can be captured. You don't get your money, right? So there are in each of the ATM machines, you can have something like, we designed something like a DC backup actually. So it's nothing but an AC/DC power supply into a 24-volt, I'd say 24-volt bus, and then from that 24-volt bus, there's a DC/DC for charging a battery, and once you lose your AC power, it should seamlessly transfer support power from the battery without interruption, so that you're able to finish your transaction, and then maybe the machine alerts and does a blue screen, and contacts the. If it were in a remote area, then it would take probably a couple of days for a technician to go there. So what's important in that condition is it has to sustain standby power, very, very small standby power. So you don't want to deplete the battery, right, before the technician comes in, so that the important information is not lost. So that's an example of one of the designs we made a while back. So some of our customers, this may not be updated, but these are, you'd see very familiar names. And then this is Advanced Energy globally footprint. So we do have in the US, Europe, Asia Pacific. And the thing with Advanced Energy is there's really a drive for innovation and technology development. So you would imagine, I think just last year, all of these centers have their own, I would say, key innovators. Basically, they're designers, very seasoned designers, and we hosted them. So globally, we hosted them here in the Philippines for we call it like a global tech summit internal to Advanced Energy. But it was a very interesting exchange of information. You'll see the different, I would say, design and development going on around the world within the company. It kind of feels like an IEEE technology summit or an IEEE conference. So that's the amount of, I would say that's the kind of emphasis on technology that we have in Advanced Energy. So this is where we are. This is who we are. We do have design engineers spread globally. We are market leading in the fields where we compete. We have engineering design centers of excellence. We definitely have a very strong patent portfolio and a huge amount of investment in research and development. So we have engineering centers, as we've mentioned, Eastwood, in Eden Prairie, Hong Kong, Shenzhen. This is really just the embedded power side of it, but you've seen in the previous slide, there's presence in Europe and across globally for the other, I would say, the plasma power generation, for critical sensing applications. So those are all part of Advanced Energy. So just I would say again, who we are here in Eastwood. It is definitely world class, and we have our own semi-anechoic chamber. We have our own test capabilities in the site. So we are really fully equipped to get into the challenge of developing cutting edge technologies. And beyond the design, where we earn money really is on the volume production of our designs. So we have state-of-the-art facilities in our factories in Cavite, Laguna, in Chongzan. And in the manufacturing side, we've received numerous citations and awards from our customers. And then we also have, we support the factory support diverse product ranges. So why choose Artisan or Advanced Energy? Really, we are an industry leader. We have very good customer relationship, and we have leading engineering capabilities around the world and a global footprint. And definitely what we develop is best in class technology. So I think this ends my presentation. So if you have any questions, please go ahead. Thank you very much.
Okay, yes. Thank you very much, Engineer Levy. That was a fantastic presentation. This is also aligned with the energy advocacy as in your presentation. Technology as well as technology driven. Okay. The presence of your R&D in the manufacturing in the Philippines helps promote this technology across the Philippines. I'm very happy to see this presentation. Okay, Zoom Master. Yes, hello. Can you hear me, Engineer Levy?
Yes, yeah, I'm trying to get rid of the slides. Ayan.
Okay, let's go to the Q&A portion. Okay, Zoom Master, can you flash in our questions so that our technical speaker can review and have his answer to the question? Okay, Engineer Levy, please do so.
Okay, that's a good question. So you're talking about so step-down transformers. When you say step-down transformers, these are the low-frequency transformers. I'm assuming you've probably seen in one of the slides SST, the solid-state transformers. Definitely that will take over because there's a demand for definitely when you process higher power, you have to make sure that you process it efficiently, and you have to also keep in mind how you can scale it. So the solid state transformers I would think is the one you're looking for in terms of going into the next stage. It's in fact already, I would say, going on in different areas around the world. And when you say solid state transformers, so you really are, instead of processing power at low frequency line, you really are employing switching devices. So yes, the devices play a role, particularly the wide bandgap devices. So I just gave a few examples, 1200 volts devices, but that can go up to 2 kV or maybe higher than that. And depending on how you process it, it could be modular also. It could be different strings where you process them in terms of modular solid state transformers. So there's also different topologies around solid state transformers. I didn't expound a lot on that. I actually touched on mostly on EV, but yes, that's the trend moving forward.
Okay, thank you very much, Levy. Zoom Master, please zoom question number 2 for our speaker. Yes, Engineer Levy, go ahead.
Yeah, good question again. This technology is fully this is implemented or adopted by the government or engineering body in the Philippines. I'm not very well versed. I'm not also sure what technology you're talking about, but I would assume it's the EV or the EV infrastructure. As you've probably seen in my slides, for the technology to take off, really, there's an aspect of support from the government, right? That's one, in terms of, I'd say, policy making, right? So let's just touch on EV, for example. I would say, yes, we are seeing majority, maybe e-trikes and e-jeepneys, and very rarely, I don't know if we have so much EV cars going on. I'm starting to see them because what's limiting could be, number one, of course, the initial cost of I would say initial cost to put them up, and cost of ownership is the other thing. But then I'm seeing once there is a support to, let's say, coming up with more charging infrastructures, and then the ease of, let's say, owning let's say an EV a vehicle. And also there are other, let's say, for the policy making, there are other incentives that they put, like if I'm not mistaken, maybe exemption in traffic reduction schemes. So that's another problem there. But then yeah, for you to adopt and to really make use of the technology, it has to come from different I would say sectors. So one is the technology side of it, the other is the cost of owning and the cost of infrastructure, the other is basically the readiness to adopt the technology. Yeah.
Thank you. Nice to hear that with the government is fully involved. Number 3, Engineer Levy, go ahead.
Yeah, that one, I'm not too familiar with metering. I would imagine that because there has to be incentive, right? For your EV to return energy, to dump it back to your distribution, there has to be incentive, right? So I would say maybe in smart grids, there might be, I'm just not too familiar, but what kind of metering there will be, but definitely there will be some form, maybe similar to, I would say, if you have your PV and you have your metering, right? So how much energy you dump in, how much power or kilowatt hour you dump in back to the distribution system.
Okay, thank you very much. Zoom Master, do we have some questions to flash in? Okay, question number 4, Engineer Levy, please go ahead.
Yeah, that's the first thought. But then I would think that you don't want to come back from your long work day and find that your EV is now totally drained. There has to be some controls to that, and some determination of how much because this is just peak demand. So one thing you have to take into consideration is it won't be supplying to the grid all the time, and definitely it shouldn't be draining your battery, so that when you come back to the parking area, you won't be able to start your car.
Okay.
But then
question,
sorry, but then again, the first premise is once there's peak demand everywhere, you better start thinking about how the grid can support that. So this is just one of it. Of course, there are other technologies. Maybe I would imagine some battery storage technologies, just really, how you can dump and support intermittencies in the grid. So this is just one.
Thank you very much. Last question. Do we have question number 5? Please do so. Count to 1. Okay, last question, Engineer Levy. Question is yours.
Okay, logistical requirements. I'm not too sure I have good insights to that. But I would say other considerations really is once you go into, just imagine people owning EVs and then the battery lifespan, and then how we get rid of, so the waste management part of it. There's also, of course, technologies into the batteries themselves, because that could be like tons of waste. So imagine getting rid of your, let's say, after whatever 5-10 years. That's one. And then the maybe when you're saying logistical requirements, if you're referring to I would say range anxiety, where okay, I stop over, I'm going to drive to Baguio, but then I need to top up somewhere. And do I have I would say, do I have a set of what's this charging infrastructure nearby? For sure there will be, I would say there's a map out. In fact, I did a quick search we have some sort of map out of where the charger for level 1, level 2 chargers in the malls, for example, that has to be there. And then, so kind of like, maybe it's also, of course, going to be mapped out in when you're using your applications, your navigation apps, like, I don't know, maybe Google Maps or what. But really, at the end of it all, it's the availability of those charging infrastructures, the kind of technology in your, how much you can draw and how fast you can draw and top up your battery, and then how long you can travel. So in terms of hundreds of kilometers per charge.
Okay, thank you. Engineer Levy, we have some 3 questions. Please, Zoom Master, message the question to Jeremy directly so that he can answer, because we have a limited question 1 to 5. Okay, Engineer Levy, please have your question answer on the chat box. Okay, and this time I would like to award the certificate of appreciation to our technical speaker. I'm requesting our Zoom Master to flash in our awarding sponsorship. Okay. I would like, once again, I would like to thank you for your unending support to the Site Engineer Levy. It helps this Port Energy and Clean Energy Colloquium a success. Okay, certificate of appreciation. This is certified, hereby present to Engineer Rochi S. Levy in sincere acknowledgement with her invaluable contribution as a resource speaker for the 4th Colloquium on Power and Clean Energy with the topic Advanced and Recent Trends in Power Conversion, given on 12th day of August 2023. As you see, we have 6 engineers sign in from Engineer Enoval, Engineer Texon, Engineer Ali, Engineer Dr. Sarcelia, Engineer Lorenzo, and Engineer Mark Philip. Okay, thank you once again, Engineer Rochi S. Levy. This is for you.
Thank you very much. Thank you.
Okay, so just stay with us, Engineer Levy, for they will message you. Zoom Master, please zoom in, flash in or message directly the question. I think I have 2 or 3 questions from the chat box. Please, and maybe you can share your question on the chat box. So right now we have a 5 minutes break. Okay. So while doing your 5 minutes break, I would like to ask again the Zoom Master for our house rule reminders and qualification for the e-certificates. So if you have that one, please flash back or flash in that requirements, Zoom Master, so that everybody will know what are our qualification to get the e-certificate. So as we know, e-certificate is very important right now, as our CPD is asking for us, especially for our license or application to level up. Okay, house rules. Okay, mute your device, respect the speakers that already been created, discussion during period. So loud and clear, it's very clear. And Zoom Master, please, the qualification for the e-certificate, which is the most important one. How to qualify for the e-certificate? So registered, remember, registered my IECEP, because our e-certificate will be on our My IECEP website. So 90% of the session to be completed. Attendance sheet is a must. Then test and evaluation is also required, and the survey as well at the end of this. So let me know, Zoom Master, if 5 minutes is almost there. So to proceed with our topic number 3. Okay, so before that, I would like to please type in yes, okay, for the chapter that I mentioned. I would like to call in the IECEP KSA-ERC, please. Where are you, IECEP KSA-ERC? Type Y if you are on the webinar so that we can see you who are here. Okay, please type Y, IECEP KSA-ERC chapter. I see 1. Okay, now can you type in your chapter name initials? Please do so. What are your chapter initials? We have Cavite, Manila, Mindoro, And OC, wow, Manila, Bicol, Cebu, Laguna, Manila again, Mindoro, SOC, so Luzon, Visayas, and Mindanao. So this is for you, IECEP nationals and IECEP chapters, okay? This is for us, one IECEP for all. Davao, yun, Pampanga. So we have too much of our attendees. I think we have almost 140 plus attendees. Thank you very much, attendees, for your unbearing support to the society. This is our fourth colloquium. So as we know, knowledge is power. So without these activities, so we will not able to see what are technologies, especially our fourth speaker or the third speaker. It was about technology on AV systems. So it's good to hear they have a manufacturer here in the Philippines, which is help us promote this in our Philippines environment. Okay, so now let's proceed for our next speaker. I would like to call in Engineer Tufilo Ongkenko, the Governor of IECEP KSA Manila, for the introduction of the resource speakers. Engineer Lorenzo, the e-space is yours.
Hello, good afternoon.
Yes, good afternoon. Go ahead.
Ayan. Okay, so good afternoon, everyone, and I am pleased to just for my okay, I'm pleased to introduce our next resource speaker. Our research speaker graduated her bachelor's degree at Divine Word College of Calapan, where she was a city scholar. She earned an education unit at Luna Goco Colleges, Inc. She got her diploma in land use planning at the University of the Philippines, Open University. Took her master in public management energy transitions at Ateneo School of Government, Ateneo de Manila. She became a technical product engineer, area sales supervisor, communications control engineer, and an instructor. And now, she's a project development officer 3, energy efficiency and conservation officer designate at Provincial Planning and Development Office. Let's welcome our resource speaker who is a licensed electronics engineer and Class B amateur radio operator, Engineer Donna Angeline Valdez.
Hello, good afternoon. Am I loud and clear? Pakinig po ba ako?
Yes,
ma'am.
ma'am.
Ayun. Siguro gusto ko lang i-correct, no? Kasi kakalipat ko lang po talaga ng work. And yun na ipasa ko kay Sir Tony was my CV during my stay at the provincial planning in the provincial planning and development office at the Capitol. So right now I'm working at the Oriental Mindoro Electric Cooperative as the strategic planning and energy trading division supervisor. Recently lang ako nagpunta doon, I think May this year. So yun yung update, no, on my CV. And thank you, sir, no? Thank you, sir, for your very generous introduction. And hello, Sir Russell. Kasi previously, parang third colloquium, tayo yung tandem as MC, no, nung ating third colloquium sa Power and Electronic Society. So again, hello, good afternoon sa inyong lahat. I'm very happy that I can be able to share with you one of my researches. And this actually research is a pandemic baby for me, no? Kasi I used to do this when I was studying in my master's sa Ateneo because I took up the energy transitions track. So yun yung story behind the study. So allow me to share yung aking Pwede na po ba akong mag-share?
Yes, ma'am. Allowed na po.
So again, good afternoon. Pakinig po ba ako? Hello po. Pakinig po ba ako? Malinaw po? Okay. So allow me to share with you my study on the renewable energy advancement to resolve the power outage problem in the province of Oriental Mindoro. Actually, it tackles the issues, challenges, and opportunities of the province. So siguro before we move on, yung ating kasing itatakal is more on a brief situational of this, and then the frameworks and findings and the strategies that we have discussed on the paper, and to give you insight and saan ba si Oriental Mindoro, ano ba si Oriental Mindoro, I would like to simply travel you konti dun sa aming probinsya. Si Oriental Mindoro is part of the Mimaropa region. So when we say Mimaropa, it's Mindoro, Marinduque, Romblon, and Palawan. So si Mindoro is actually dalawa yan, sister sila. So we are in the eastern part, si Oriental, and then si Occidental. No? So ang study is more focused on Oriental. So si Oriental Mindoro envisioned to be an agri-ecotourism destination within the Mimaropa region, with an environment conducive to investment. So again, because si Mindoro is an island, it's more on agriculture based, no? And then we have also boosting economy when it comes to tourism. So sino ba naman hindi makakilala pagdating sa Puerto Galera, no? Sa Bulalakaw, yung mga beaches namin. So yun doon nakikilala si Oriental Mindoro. And ang total population of Oriental Mindoro as of 2020 census, we have 908,339. And yung area niya, land area niya is 4,238.38 square kilometer. We have an average growth rate of 1.56%. So sabi nga, when it comes to economies, from the previous PSA data on ranking dating dun sa economic share dun sa buong region, si Oriental Mindoro daw is second, no, rank, followed by Palawan. Actually si Palawan yung top 1, and then si Oriental Mindoro yung top 2. So 2020 data of the PSA. And then because growing nga si economy ni Oriental Mindoro, and alam natin na when it comes to growing economy, it's to have a sustainable and reliable power is a requirement, no? So pagdating sa power, si Ormeco, no, or Oriental Mindoro Electric Cooperative Inc. ang nagsusupply ng power sa Oriental Mindoro under Section 70 of the Republic Act number 9136, or the Electric Power Industry Reform Act, or IPIRA of 2001, area no na nasasakupan no ni Mindoro, ni Ormeco, which is an off-grid area. When we say off-grid, it's not connected to the high voltage transmission system or the grid, no, is mandated, no, by the National Power Corporation, Small Power Utilities Group, or the NPC-SPAG. And si Ormeco has 10 power providers. We have the independent power providers na regularly nandyan, and then kapag kinakailangan, they have emergency power providers. And on the IPP side, we have they have majority no ng power source natin is from diesel. So 72.85% of the total dependable capacity is from diesel talaga. Although we have renewable energy sources na ginagamit na, we have 4 mini hydros and 1 wind energy. But still, kung titingnan yung operation no, ni Ormeco, diesel pa rin yung pinaka major source natin o primary source ng supply doon sa buong probinsya. For renewable energy, that is 27.15 of the total dependable capacity. No, that's actually total doon sa 5 na renewable energy. When it comes to supply and demand, no, according dun sa Oriental Mindoro Facts and Figure 2001, which is also galing din naman sa Ormeco's data, no, the average dependable capacity of the province is 68.54 megawatts. And yung recorded peak demand during that time is 49.24 megawatts. But the annual growth of energy demand is 5%. Which is very high compared to the annual growth rate ng ating population. So meaning to say, nabilis talaga, no, nagbo-boom talaga yung economy ni Oriental Mindoro na nangangailangan no, ng support ng reliable, affordable, and efficient no, power. So, ano ba yung mga consumer type ni Ormeco? So, most consumers are residential type, no? And kasi nga, agriculture-based si Oriental Mindoro, so kung mapapansin nyo, yung industrial part is very monte, no? Compare doon sa residential. So, kasi mas madami talaga dito yes po. Yes po.
Can you please reshare your presentation?
Slides?
Yeah, the slides presentation.
Nag-stop po ba?
No, there are some blocks.
Okay po.
Blocking your presentation. Can you reshare it and proceed with the same slide?
Wait lang po ha.
Yeah, this one. You see, we see some blocks. I think there's a word there, or just reshare it.
Yes
Is
po.
this PowerPoint, right?
Canva po. Canva.
Canva. Okay.
Nakikita, paano ba? Wait.
Yeah,
Stop ko lang po ha.
Just reshare and let's try. And proceed with the same slides. Slides number.
Stop share ko lang, sir.
Yeah, yes, go ahead.
Yan, nakikita na po ba?
Yeah, the same. We can see black.
Paano ko ba ito maalis?
I think it's from the Canva. Yeah, go ahead.
Yan, nakikita, paano po ba?
Same. Please advise our host Canva users if there's something we can do, or we will proceed. We can nothing to do. Yeah, what we see down here, there's some black box that I think it's a messages that we cannot see what exactly.
Hello, Ma'am Donna.
Wait lang po ha.
Yeah,
Ay,
yes, go
sige
ahead.
po, sir.
Ma'am, ganito po. Please share it as screen, not as document. Share screen, not share as document.
Okay, try
Oh, share screen.
your screen.
Yes po,
Screen.
share screen.
Yan.
Share your screen, yeah. Share your screen.
Pero kanina.
Okay, yeah.
Yan na. Okay na po?
Bigger. Yeah, make it bigger. Okay, clear. Can you go back?
Clear na? Clear na po.
There's still
Saan
something.
ako mag-start ng dito?
Doon yung sa taas ng right side, may nakasulat ba dyan o wala?
Wala po. I think yun yung mga mute, stop video, ganun yung nakasulat.
Okay. That's clear. Okay, go ahead. So it's clear now.
Okay, yun po. So malinaw na po dito dun sa
Yes,
consumer type.
Yeah. The graph is graph, yeah. Only some blacks. Okay.
These are pop-up sa Zoom nyo po. Paki-close po yung mga pop-ups nyo sa Zoom.
Ano ba ito? I-close.
X, can you X?
Walang X.
Pwede po hide floating panel. Thank you.
Hide floating panel daw. Saan siya? Sa Zoom siya or
Video
sa...
panel. Yan. Ganyan.
Oh, ito. Mayroon pa
Yes
rin
sir,
ito.
sa Zoom po.
Yun. Yan. Okay na po?
Meron pa rin. Try daw mo
Wala.
other
Yan.
slide. Okay, move
Parang
to other.
wala na po akong
Yes,
nakikita.
Okay na po.
Yan, okay na po.
Okay
Thank you,
na
ma'am.
po. Ayan. Thank you po.
for the help.
Okay.
Go ahead now, Dom.
Okay po. So, ito yung consumers type ni Ormeco. No, again, we have more on residential. It's actually 174,597. And when we look at the electricity rate per customer and compare it to its neighboring provinces, no, kung makikita nyo yung bold line dito, papansin nyo na si Ormeco have higher, actually highest among the neighbors yung kanyang electricity rate from residential to commercial, industrial, public building, and street light. And when we look on the comparative rates from 2021 December to August 2022, we can see that nag-i-increase yung kanyang power rates in terms of consumer type. So ito yung mga ibang data na tiningnan natin why despite of having a renewable energy supply in Oriental Mindoro, frequent pa rin yung power interruption na nararanasan nung province. We can see in the interruption index report in 2022 that ito yung unscheduled because meron dalawang klase ng interruption na pagdating na tinitingnan ang Ormeco. We have this scheduled, which is ito yung mga annual maintenance ng ating mga suppliers, and then ng transmission. And yung mga unscheduled, ito yung mga biglaang trippings, So kung makikita natin from the slide, pag kinumpare siya into target, mababa siya. But it's already higher, Kasi ang experience nung mga consumer is frequent. When we say, like dito sa November, December, makikita nyo ang dami nung interruptions ng kuryente. And may mga times na dahil nung time ng pandemic, madaming mga pagkakataon na busy ang tao sa pag-visit ng social media. Every time nagkakaroon ng interruption, mabilis ang absorption ng consumer na ay bakit walang kuryente, So doon yung time na nababash ang province, ang Ormeco, na bakit ang dami-dami lagi may interruption, ano ang problema. And ako din kasi during that time ako ay I'm studying online, and habang nagre-report mo biglang mawawalan yung kuryente. So that time na totoo, tama, dapat pala siguro pag-aralan bakit nga ba laging may power interruption and ano ba yung maitulong ni renewable energy pagdating sa power interruption ng province. Yun yung time hanggang sa nagkaroon na ng tag si Oriental Mindoro as one of the brownout capitals ng Pilipinas. Siguro naman lahat halos ng rural areas na tag as brownout capital of the Philippines kasi medyo mahirap pagdating sa off-grid areas na ma-maintain yung kagaya ng nasa grid tied areas na laging may kuryente. Kasi yung nasa off-grid areas, ito yung mga area kung saan nakadepend lang sila doon sa kung ano yung mga contracted na capacity ng mga suppliers nila. Na yun yung magsusupply, yun yung magbibigay sa kanila ng service. So beyond the demand, beyond ng demand versus doon sa capacity ng dependable ng mga suppliers, doon nagkakaroon ng power interruption. So, ito yung mga nakikita nating scenario ng probinsya. We have frequent power outages, mataas yung energy demand niya o nag-i-increase yung energy demand niya. And ang isang concern dyan is because of grid area nga siya. And then, when it comes to protecting our environment. Diesel kasi yung major source of supply ng province, which is very crucial when we talk about climate change. But when we look on the brighter side, taking the opportunity of what the province have, we have abundant renewable energy sources. Actually, we have a hydro, and then we have wind, and we are in the island. So, napapalibutan kami ng tubig, no? And maraming mga beaches na there are potential renewable energy sources na pwede nating ma-harness, no? And there are existing laws, policies that supports renewable energy development in the off-grid areas, no, which I will give you some in the later part of the discussion. So the problem statement of this study is how can the advancement of renewable energy through public-private partnership or the PPP resolve the power outage problem in the province of Oriental Mindoro? I involve PPP here because again, nung ginawa ko to yung study na to, I am working at the provincial government of Oriental Mindoro, and I believe in the power of collaboration with the private. No, collaboration of public and private partnership. Mas nagiging stable yung isang programa or isang project when there is an involvement of the public and the private. No. So the other secondary problems are what are the issues and challenges encountered by the stakeholders in addressing the power outage in the province? What are the opportunities for renewable energy development in the province, and how will the province develop a sufficient supply of renewable energy through PPPs? And the objective of this study is to determine the power issues and challenges encountered by the energy stakeholders within the province of Oriental Mindoro, and then to evaluate the stakeholders' action in resolving the power issues, determine the opportunities of developing renewable energy to resolve the power outage, and demonstrate the importance of PPP in renewable energy advancement in Oriental Mindoro. Actually, the significance ng study is, first, is for the provincial government to help in their power development plan. Actually, during that time, ang province ay wanted to develop, no, or to pursue yung development ng power development plan ng buong probinsya. And I believe na yung study na to is makakatulong in developing, no, pag-identify ng mga challenges, issues, and opportunities ng province pagdating sa usapin ng electricity. The conceptual framework of the study, ito yung nabuong concept, no, nung study, that we look at both sides, both the private and the local government. We can see here that the renewable energy sources, both the private and the local government have access in using and developing the renewable energy resources in the province. And if they collab together, being a public-private partnership, they will be able to address the power outage issue, which is very crucial in the growing economy of the province. Ito naman is yung mga related studies that supports yung study natin for the province of Oriental Mindoro, taking into consideration how important is sustainable, reliable, and climate resilient power supply in the growing society. We also have studies na nagsusupport na importante, no, yung gamitin yung renewable energy natin, especially in rural areas, because it will address yung energy problem natin. Kasi pag sinabing rural areas, nandun yung mga unenergized area kung saan hindi nare-reach, no? Na imagine 2023 na may mga area pa na walang kuryente. So, eto din yung time para yung PPP, no, ma-involve pagdating sa development or paggawa ng mga innovative solutions to implement o integrate yung renewable energy natin para makapag-supply, no, at ma-develop yung mga areas na magkaroon naman ng quality of living yung mga tao na nasa malayong lugar. So sabi nga, sa well-planned PPP arrangement is a major component in energy investment and strengthens the government approaches to achieving the sustainable development goal and ensuring access to affordable, reliable, sustainable, and modern energy. Then if we work together to understand the global energy crisis and embracing that efficient utilization of renewable resources is the best possible solution to reduce our dependence on non-renewable resources. So ito naman is mga basic laws and policies that will stand up para sa mga rural areas kagaya ng Oriental Mindoro to develop more renewable energies. We have the Republic Act 9136 again, the EPIRA, the Electric Power Industry Reform Act. According to EPIRA, ito yung nagka-qualify to reform the booster effort of the rural or the missionary electrification. Pag sinabing DUs, the distribution utilities, responsible daw siya to provide universal service. Ship power supply, function of DUs, una is to introduce the qualified third party to undertake both power generation and distribution services in areas that the DU waive. Ito yung mga missionary electrification mandate under ng EPIRA na given to the NPC SPAG as the electricity provider of last resort. Establishment of the universal charge for missionary electrification to subsidize missionary electrification activities. Ito yung mga importanteng privileges ng EPIRA para doon sa mga rural electrification. So, meron tayong tinatawag na universal charge for missionary electrification, yung fund. Pag ginagamit natin is more of renewable energy. And we also have Renewable Energy Act, that is RA 9513 of 2008. This act promotes the development and utilization and commercialization of renewable energy resources and for other purposes, like you require the issuance of RE service, operating contract to a developer, or for the right to explore or develop renewable energy in a particular area. It also provides fiscal and non-fiscal incentive for developing RE projects, introduce new market mechanism like yung mga net metering for renewable energy, renewable portfolio standard or yung RPS natin, and yung feed-in tariff system, and then we have the Green Energy Option Program or the GEOP. Also provides that qualified and registered renewable energy generating unit shall enjoy priority dispatch. When it comes to dispatching naman, yung labas nung energy supply, pag-deliver doon sa consumer, pinaprioritize yung mga renewable energies natin. And then we have the National Electrification Administration Act, the RA 10531 of 2013. This introduced the structural reforms in the NEA and the ECs to strengthen the institutional capacity to undertake total electrification. ECs are given new mandates to allowed to construct, own, acquire, operate, and maintain electric substation, sub-transmission, and distribution lines, and to engage in power generation activities within its franchise area. So this one is a very good law actually, because ito yung nagbibigay ng karapatan o ng engagement para doon sa mga rural areas na mayroong mga electric cooperatives na gustong mag-engage din sa power generation. Although si Ormeco naman, meron siyang owned na 2 hydro, and those are both mini hydros found in Baco, situated in Baco. So, actually pinapractice na rin ito ni Ormeco. And then the other policies issuances na recently lang, no, maganda ding tingnan, no, tiningnan din during the studies, yung Microgrid System Act, which is DRA 11646 of 2022. Ito yung ito is naka-focus on the power generation. No? It helps in the power generation ng mga electric cooperatives na gustong mag-engage into power generation ng renewable energy. No? And we have the Executive Order number 138 of 2021, or the EO 138. This naman gives the LGU the capacity to collaborate with the distribution utilities or the electric cooperative and other interested parties in the promotion and implementation of initiatives to achieve the energy self-reliance and universal energy access within their jurisdiction. And then for the findings, lumalabas lang. For the findings, we can see that there are issues na meron, no, pagdating sa energy, si Oriental Mindoro. Una-una is that there is an increasing fuel cost in the market that directly affect the overall operation of the non-renewable IPPs in the province. So, tumataas si fuel, eventually tataas din si electricity rate. No? Climate change affecting the IPP's generation of electricity, particularly the renewable energy sources. So yung generation, we have per high-post wind, no, in the province of Oriental Mindoro. It's really affected by the climate change. Maraming times, no, na wala talagang generation ng wind energy, and mababa yung generation naman ng ating hydro. So, naapektuhan nun, of course, the efficiency of the electricity na siniserve sa consumer, as well as yung electricity rate din. No? Kasi doon nagkakaroon kapag mababa ang kanilang generation, nagkakaroon tayo ng emergency power suppliers na sila naman yung mapupuno, which is a little bit higher than yung rate nila, no, compared to the existing renewable energies natin. And then we have lacking of appropriate planning and system to determine the power supply and demand of the province. This is both actually in local government and the ECs. No? Kasi yung appropriate planning dito na sinasabi is yung collaboration of their plan, no, together. So mas maganda sana kung ang plan nga nila is nagmamatch together, no, or iisa lang to support yung increasing demand of the province. We also see issues in the numerous unscheduled maintenance due to the faulty equipment and interrupted or grounded transmission lines within the franchise area. So kung makikaalala natin kanina yung SID at SID. So maraming unscheduled, no, na interruption na nagaganap. Although it's below the target, but still it's madami pa rin, no? It's beyond 50%. And considering that the province geographical location is very vulnerable to many natural hazards like typhoons and heavy rains. And because island nga si Oriental Mindoro, no? So marami lagi, taon-taon na may typhoon. Pag lumakas ang hangin, lumakas ang ulan, naapektuhan talaga yung transmission because mahaba, no, yung transmission niya, no, dun sa from Calapan City to Bulalakaw. Mas mahaba yung 69 kV. So mabilis siyang maapektuhan at mawala ng kuryente, no? Pagka may mga heavy rains, malakas na hangin, malakas na ulan, lalo na kapag gabong. No? So to help, no, yung discovery ng mga issues natin, tinignan natin, no, we dig in more and we want to answer more questions to really understand the power situation of the province, no. And these are the questions that help us in discovering kung ano ba yung mga problema pa, no, mga issues and challenges, and mga possible opportunities na pwede nating makita, no, to help na magkaroon ng sustainable, reliable, and affordable electricity ang province of Oriental Mindoro. So, we look at the frequency of energy-related problems in Oriental Mindoro. So, from the number of respondents that we have, tinanong natin sila kung ano-ano ba yung mga energy-related issues, and these are the energy-related issues na nakita na nabanggit nila. And then, ang pinaka mataas doon is yung mataas yung electricity rate, and then madami, frequent yung brownout. So, it's around 100%. No. Others are poor in service, unpredictable yung performance ng RE, EC is not ready to implement net metering program, absence of energy plan, climate change, old at damaged na yung transmission line, old na yung mga power plants, then may nag-mention ng bureaucracy, then slow action ng ERC, NEA, and DOE. Because during that time, nagkaroon ng issue kasi ang mga power providers pagdating dun sa universal charge missionary electrification nila na fund na nakukuha. Ito kasi yung mga nare-reimburse nila, no, sa SALM para din sa mga dinidistribute nilang energy. And then we have interrelation, findings for the interrelation with power outage in Oriental Mindoro. I don't know if I can make it big. Parang hindi. Hindi ko siya mapalaki. Ay, iba yan. Ayan. Dito makikita natin si power outage, no? Siya yung center. Ano ba yung meron kay power outage? Bakit nagkakaroon ng power outage? So nakita natin, we have maintenance, power tripping, the natural hazards, and the load shed. No? Under ng maintenance, we have the unscheduled and the scheduled. So pag sinabing unscheduled, ito yung mga corrective maintenance natin, na sometimes ang reasonan is obstruction in transmission and disruption ng lines, ng mga short circuit, no? Kaya nagkakaroon ng power tripping. Sometimes meron ding issue for pilferage, no? Affected siya ng pilferage kaya nagkakaroon ng power tripping. And then kapag scheduled naman, ito yung mga annual maintenance natin, no? Transmission line rehabilitation. And ang reason nito, kasi nagkakaroon ng annual maintenance kasi medyo damage na yung transmission line, mga ano natin, old na. So para ma-avoid din yung tinatawag ng system loss. Kasi pag tumataas sa system loss, kakaroon din ng effect yon sa ating electricity rate. So kapag load shed naman, no, paano ba nagkakaroon ng load shed? Over yung demand natin, nasi-short yung power supply natin. And kapag ka-over yung demand, ano ba yung mga nakaka-apekto, no? Wag over yung demand. Siyempre tumataas yung number of population, nag-grow yung economy. And during that time, pandemic kasi, no? So mas mataas yung demand. Yung sa shortage naman ng power supply, meron tayong mga power plant failure, meron tayong, kasi old na yung power plant, no? Meron tayong RE low, no? Zero power generated. Banggit ko sa inyo kanina, merong times na hindi nag-generate si wind, meron times na hindi makapag-generate si hydro. No? Yung mga non-RE providers natin, nagkaroon ng during that time, may financial concern nga sila. No? So, nadidelay yung subsidy nila. So, nagkakaroon sila ng limited fund to buy fuel. So, kaya nagkakaroon siya ng load shed and eventually, it affects yung performance. No? Nagkakaroon ng power outage. And the natural hazard, which is because of the climate change, meron tayong mga typhoon occurrence, no? May mga flooding. So, yun yung mga nakaka-apekto sa power natin. No? So, kaya nagkakaroon ng power outage. So, yung frequency of mention ng reason ng load shedding, kasi nabanggit, kung napapansin nyo kanina, yung blue part is napakalawak. So, yun yung part ng load shedding. So, tinignan natin ano ba yung mga reason bakit may load shedding. So, tinanong natin. No? So, tinignan natin during the month of January to August. Ito kasi yung time na kinonduct yung research. So dito may pinakamataas yung low and no production of renewable energy suppliers. Walang production ng ating renewable energy. Mostly wind, and yung hydro natin is minimal. And then meron tayong shortage ng power supply of non-REIPPs. Kasi ito yung time na nagkaroon sila ng mga problems sa kanilang funds. And then others are yung power plant technical failure, avoid overloading of substation, preventive maintenance schedule, feeder connection modification, line improvement correction of activity, emergency power interruption. So ano yung mga ginawa nating actions, despite of the challenges and limitation of the electric cooperative, of the government, of the PPP in resolving the power outage sa province of Oriental Mindoro. So actually tatlong entities to. We have the electric cooperatives, the PPP, and the government, the local government. So for the electric cooperative, we provided action plan programs and projects, no? For the policy, karon sana 100% collection efficiency, no, by the partnership with banks. No, kasi may nagkaroon ng usapin about collection efficiency, si Ormecos nakakaroon ng problem pagdating sa collection efficiency sa consumers nila. So kasi sila ay non-profit organization, kailangan na yung fund, no, kung ano yung ibinenta nila, bumalik din sa kanila para mapaikot nila. Kasi yun din yung ibabayad nila sa mga suppliers. And then yung austerity measures of co-ops, na expenses through the austerity of fuel consumption expenses and no hiring of no employees. So sa program project nila, pagdating sa collection efficiency, ito nga yung balancing yung energy and demand supply ng province. And then may nakita nating single digit system loss, no, dapat yun yung ma-maintain nila. Kasi once na tumaas si system loss, no, kung maalala niyo yung talk kanina ng second speaker natin, na kapag yung losses, no, ng isang distribution ay mataas, big sabihin, yun din ay mai-pass through din sa consumer. So pagtaas nun, waste kasi yun, no, pero still babayadan pa rin siya ni consumer. So hangga't maaari i-limit, no, yung system loss natin. Then negotiate procurement of emergency power supply. Ito kasi during that time it has yung 22.3 megawatts ng Ormeco, no. Then the power supply procurement for 2023 to 2030. Yung competitive selection process, I believe itong 55 megawatts capacity that time yun yung pinopropose nila. Then nag-down to 41 and then parang nanalo siya, no, ng ERC. And then nakita natin yung mga challenges and limitation ng electric cooperative. Kasi consistent yung implementation of information, education, and communication campaign ng member consumer, no. Dapat nakita natin na malaki yung epekto kapag nai-inform natin, nabibigyan natin ng tamang kaalaman yung mga consumer natin sa kung ano ba yung nangyayari pagdating sa operation ng electric cooperative. So may impact siya, no. Sabi nga, knowledge is power. Kasi kaysa i-bash ka na i-bash, let them know, no, kung ano yung nangyayari. No. Then meron kasing limitation si Ormeco pagdating sa technology. And we also sa financial na capacity. And there is no continuity din ng program due to changing yung management. Wala kasing long-term plan para during that time si Ormeco. So ilan ito sa mga nakitang challenges and limitation sa electric cooperative. Pagdating naman sa local government, yung mga challenges and limitation, maraming programa si local government na gustong gawin, but it limits pagdating sa usaping net metering na, no? Because it's not yet implemented in the province. And sabi nga, it is because the province is an off-grid area, wala pa, no, wala pang policy, net metering pagdating sa off-grid area. And also the province or the local government have lack in financial and technical capacity to monitor yung mga project niya. No? And then wala pa siyang committee to focus on the power and energy concern in the province. That's why this study sana nga is nakatulong sa pag-create nila ng power development plan. And then inside the power development plan is the creation of the power committee, or power and energy committee. Ay, sumatalo yung ano. So ito yung mga strategies na gusto nating tingnan pagdating sa local government is to upgrade and maintain yung databases nila, i-create or adapt nila yung local PPP code, deliver and manage performance indicator, i-ensure nila yung execution of energy policies and programs na mandated by the national agency sa local government, mag-create ng legal framework to guide the energy sector, and i-organize nila yung energy council. And for the PPP center, because PPP center is there to help to capacitate the local government as well as the private agency, is them to accelerate the formulation and implementation of the concept and framework for renewable energy. So during that time, wala pa yung, parang dinadraft pa nila yung framework for renewable energy. And for them to disseminate awareness through capacity building of LGUs, particularly those in the off-grid areas. Kasi nga medyo may lack in communication doon sa PPP center and the local government. Hindi nila alam na pwede palang ma-access si capacity building ng PPP center to help them capacitated doon sa mga area na sa mga technology na hindi nila pa gaano gagamay na po. And for the electric cooperative, first is to synchronize their plans with the LGU to elevate action and to avoid duplication. Ito kasi isang pinakamaganda para ma-minimize din yung duplication or use nung ating budget is to have them synchronize their plans. And yung establishment ng 24/7 customer helpline to assist the member consumer in their technical problem is a big help for the consumer as well as for the electric cooperative, kasi hindi naman nila agad kita yung nangyayari sa lahat ng consumer. And if the consumer inform them, mas mabilis ma-actionan ng electric cooperative yun. And to implement the net metering program in development to develop more prosumers. So sana pagdating ng araw magkaroon ng net metering program na pagdating sa off-grid areas. It will help really develop more prosumers, and then engage in more power generation using available renewable energy sources. So kanina nakita natin nga na may mga supporting laws naman tayo and policies to help the electric cooperative generate more or engage more in power generation. So I think this will guide the electric cooperative to be able to engage in more renewable energy in the future. So I think that's all for my discussion. Thank you for listening.
Hey, Engineer Donna, we are very thankful for your unending support to the society as well, your knowledge sharing to our fellow SEs. It was outstanding presentation. Engineer Donna, thank you very much. Okay, we will proceed with the Q&A portion. Zoom Master, please flash in question. Engineer Donna, the question is yours.
Basahin ko na po, Sir Russell.
Yes, go ahead.
Okay, question 1. What are the causes of power interruption managed by Power Co-op? In your own opinion, what are the things needed to improve? Share some example. Dun sa study natin, yung mga causes ng power interruption, medyo marami talaga. Inabanggit ko nga sa inyo kanina, meron tayong mga unscheduled scheduled interruption because meron tayong talagang program sila para doon. No? But on the unscheduled interruption, ito yung mga medyo alarming pagdating sa consumer. Kasi it should be beyond the control of the electric cooperative. But there are cases na hindi talaga siya makontrol ng electric cooperative kasi merong mga instances na halimbawa nagkaroon ng sunog sa transformer o kaya sa mismong poste, no, which is sobrang init ng panahon, or kaya naman mas lumalakas yung hangin, may mga instances na yung ating transmission line is nalalagyan ng mga unwanted na palapa ng niyog o kaya mga na hayop na pumupunta doon sa umaakyat doon sa mga poste natin na nagkakos ng power interruption. And part din ng mga power interruption natin is yung problem ng mga IPPs kasi nga tayo is as an off-grid area, no, prone kasi si Ormeco sa mga kung ano yung problema ni IPP, absorption ni Ormeco and then ma-absorption ni consumer. If si IPP have problem in financial to buy yung fuel nila, nagkakaroon ng lack of fuel. So sabihin magkakaroon ng lack of supply. Si Ormeco, bibigla doon. So magagawa niya ng paraan. And of course, yung in-between doon, yun nagkakaroon ng power interruption. So yun yung mga instances. And yun nga, nabanggit ko sa inyo kanina na meron tayong renewable energy. But of course, there is a need for intervention dun sa innovation ng technology. Kasi medyo maliliit lang yung mga renewable energy natin dito. So sa probinsya, meron tayong hydro na kapag sobrang lakas naman ng ulan, hindi pa rin siya makapag-generate kasi nga baha naman. Kapag wala namang ulan o walang sobrang init ng panahon, hindi din siya makapag-generate kasi may igay yung tubig, low level yung water niya. Same din case doon naman sa wind, kapag walang hangin, totally wala talaga siya ma-generate, hindi siya pwedeng makapag-supply ng power. So yun yung mga cases natin na uncontrollable. No? So na hopefully makontrol in the future.
Okay, thank you, Don. That's a good insight from your own opinion. Question number 2, Zomaster, please zoom in. Okay, Don. Go ahead, Don.
Okay. Question number 2, may we know what are the future plans of Oriental Mindoro LGU to at least lessen the power crisis in the area? Aside from solar or wind, is waste to energy or sea wave energy a possible secondary source of energy in the area? Okay, thank you for the question. Kasi when I was in the Provincial Planning and Development Office, I used to draft yung power development plan, which is still hindi pa rin siya tapos pero yung future plan talaga ni Ormeco to lessen yung power crisis natin sa area ay kasama na kasama yung ating pag-develop, pag-engage sa mga renewable energy. Kasi we wanted to make sure na ma-address din natin yung objective ng ating national government pagdating sa ating target on renewable energy by 2030. So aside from solar or wind, yes, yung waste to energy actually we have nung nandito na ako sa Ormeco, I encountered one of the IPP developing the waste to energy. But hindi pa ito nag-start. I believe meron lang silang concern on the waste na magbibigay ng sustainable waste para doon sa waste to energy nila. But hoping na by next year daw mag-operate siya. Yung sea wave energy, I don't know if there is, but what I know, the NPC right now is on the bit of studying I think wind energy pa rin on the southern part of the province. Pero parang floating, some kind of a floating wind energy doon sa area. And yung existing nating wind provider dito. They are also studied to put wind energy din dun sa southern part. So more on wind, solar, and waste to energy. Si Ormeco is something into renewable na din, which is very, I'm happy to to announce that. Kasi aside from the hydro, gusto na rin ni Ormeco involved into solar para mas strengthen yung renewable energy development sa probinsya.
That's a good initiative, Don. You are there, so the right timing for you to be there. That's a good sign. Okay, question number 3. I will read for you. Are there any government programs in the province introducing energy efficiency and conservation in residential areas? Example, the use of LED and inverted type ECUs. Go ahead, Engineer Donna.
Yes, actually meron. When I was in the PPDO, I was designated also as the Energy Efficiency and Conservation Officer during that time. And actually, yung campaign for the using of LED and inverter type ECUs appliances for residential, hindi pa siya ganun nag-boost. But for the government offices, we actually initiated to, I think it was year 2021, 2021. Nag-start na kami i-convert yung mga light sa mga LGUs, municipal, city, and the provincial level, including the hospitals na operated by the government, as well as yung inverter type ng air conditioning units. Yes. But for the residential, I actually included in the draft provincial power development plan to strengthen yung pagkakaroon ng information campaign on how important is the role of everybody when it comes to energy efficiency and conservation.
Okay, thank you. Just question number 4. Do we have Zoom Master? Okay, Don, I will read it for you. What were the recommendations of the House of the Senate during the last March Senate hearing address to Ormeco concern? Is there any assistance offered by the legislation? Go ahead, Engineer Donna.
Hindi na ako informed sa recommendation ng House of the Senate, but I think it's more on renewable energy to address. Kasi and to address yung power outage. Totoo yun. Kasi yung problem kasi ni Ormeco, actually si Ormeco yung sumasalo talaga when it comes to problem ng power outage sa province. Kasi nung time na yan, nagkaroon ng problem, parang na-involved na. Actually, alam na ng national and local government ano yung situation ni province. Naging controversial yung pagkakaroon ng power outage. And yung offered assistance, as much as I remember, siguro, wala akong maalala, wala pa akong maalala ang offered assistance ng legislation. But more on they are hearing na they're involving as ako more on sanggunian they're involving in pagka nagpo-procure sa Ormeco and the emergency power kasi they're need nila ng emergency power to cope on the demand of the province. Yun yung mga naigiging contribution ng legislative. Pagdating sa infrastructure, wala akong but I believe yung ngayon nating Congress, they are into dealing with renewable energy. They love to develop more renewable energy kasi yung future ni Oriental Mindoro, as much as I remember, they are eyeing to be interconnected into the main grid, no? In the future pa naman. But yun yung gustong maging trend, no? Yun yung gustong maging pagdating ng araw. So ito sa tingin ko yung tinitingnan nila, no? Na magiging future ni province para mawala na ng power interruption.
Okay, thank you for that. So last but not the least, we have question number 5. Zoom Master, please zoom in. And Jonah, I will read it for you. What are the future studies that we can do to help solve power outage problem in Mindoro and other parts of the country? This is particularly the cooperatives done in the province. You know, province power interruption every day, especially in my province. So what are your
Future studies
so-
siguro. Actually, pagdating naman sa study, wala naman talagang limit, ano, as long as bigla kang ma-involve doon sa situation. But for the future studies, magandang tingnan kung ano yung merong energy resources doon sa isang lugar na pwede natin bigyan ng pansin, no? Like halimbawa, applicable ba si solar energy? Is that really the solution to help fill in the gap between the existing renewable energy, no? To sustain yung power talaga, yung electricity dun sa isang lugar. I think yun yung maganda. Maganda din study yung grid, no? Connection natin. Kasi maganda ba talaga siyang, makakabuti ba siya talaga? Or is masosolve ba niya talaga yung problema ng power outage ng province? Kapag siya ay interconnected na sa main grid? Parang nga ganun. Siguro ilan yan sa mga pwede nating bigyan pansin, no? Kasi ito yung mga for the future din na development ng ating province.
Okay, thank you very much, Don. Engineer Donna, we have, I think there's still question number 6. Okay,
Are there plans to establish solar farms in the province of? What is the status now with regards to the implementation of solar technology? I think ngayon mas alam na, no, more aware na si province pagdating sa solar farms. Before I go to Ormeco, meron kami in-implement, no. It was funded by the DOE and together with the UNP, may mga mini lang naman na solar rooftop kami na-distribute doon sa mga pili pa lang na parishes and LGUs para makita nila, no, yung use and benefits of having solar installed in your vicinity. So meron bang plan to establish solar farms? Naririnig po ako na establishment ng solar farm, and maganda sana nga po kung meron. Kasi and I think isa din to sa magandang study. But meron po tayo, no? And Sir Meco nga, nabanggit ko sa inyo kanina, meron siyang plano, no, to put up a solar farm para support no, doon sa renewable energy target ng ating bansa.
Okay, thank you very much. Zoom Master, do we have one more? Question 7 for our speaker.
Yes. If you have an idea, engineer, how is the support of Ormeco with regards to net metering application? So again, actually si Ormeco naman, once it is mandated, no, to electric cooperative, susunod siya. But as of now, wala pa po kasi guidelines for net metering pagdating sa mga off-grid areas. But I believe ay hindi po tatanggi si Ormeco doon. As ang kailangan lang siguro is capacitation ng tao and para ma-adapt yung technology.
Okay, I think we have to end the question answer so that we can accommodate. Zoom Master, please direct PM the question to Engineer Donana. Engineer, please do so so that we can accommodate all your questions. Now, Zoom Master, it's this time I would like to award the certificate of appreciation to our technical speaker, Engineer Donna. I am requesting the Zoom Master. Now you can see your certificate application. And I would like to thank you once again for your unending support to the society from the first until this fourth colloquium. Thank you very much. This is without you, it will not be as successful. Okay, Donna, the certificate of appreciation is certified hereby to present to Engineer Donna Angeline Valdez in her sincere acknowledgement with her invaluable contribution as a resource speaker for the fourth colloquium on the power and clean energy with the topic assessment on renewable energy advance to address power outage problem in Oriental Mindoro province given on the 12th day of August 23. As you see in Jornada, 6 engineers are signed in: Engineer Enoval, Engineer Texon, Engineer Mauna, Engineer Sarcelia, Engineer Onkenko, not but the least, Engineer Fernandez. Engineer Nora, accept this certificate of appreciation. Thank you once again and see you on the 5th colloquium. Thank you, Bernjana. This is for you one more time. Hey, before we will proceed to our next topic, I would like once again for the Zoom etiquettes, please mute your microphone if you are not called or if you are not uh, you are not answering some questions so that it's very clear to the audience. Once again, Zoom Master, do we have audience in the YouTube? Please acknowledge. Do we have YouTube audience? I think there's a YouTube. Can you type why if you know there's a YouTube audience, especially our students? If there is, kudos to all to our YouTubers. So thank you once
Hello,
again.
Bradras. Yeah, we're not broadcasting on YouTube live at the moment. Yeah,
So I think
we're only here on Zoom.
Okay, so nevertheless, we have 146 attendees. So, Engineer Donna, thank you once again. Now we will proceed for our topic right away. Zoom Master, please flash in for our introduction of the speaker. Zoom Master, please flash in our, okay, where are we now? So, for a webinar topic, by the way, do we have a student here on this Zoom webinar? Please acknowledge. Engineer Tony, you have some student, right?
Yes, we have students. Our technical team, Bradras, are the students from Cavite chapter.
Kudos to you all IECEP student chapter. Thank you for your full support to this society. One of these days you will be our future engineers. Okay, now let's proceed to our next speaker. I would like to call in Engineer Yuxon, the governor of IECEP Mindoro. Engineer Gerald.
Hello.
This space is yours. Go ahead, Engineer Gerald.
Okay, as energetic as always, Engineer Russ. Thank you. Okay, so to introduce our next speaker, he has for his career highlights in abroad. He's an instructor in University of Technology in Applied Sciences, a consultant in multiple international companies such as Vitamin Projects, Ericsson Site Engineering Design for Mobile Networks, RAEC Power Plant Rehabilitation, and many others, as well as a technical trainer in Institute of Technical Training Services, LLC. And for his career highlights in the Philippines, he is instructor in AMA CLC College in Butuan, operation and maintenance engineer in Philcom Corporation, broadcast station engineer in GMA 7 TV, and 102 megahertz FM and MBS broadcasting. He's also an instructor in St. Joseph Institute of Technology. His professional qualification are the following: Filipino ASEAN Chartered Professional Engineer since 2022, ASEAN Chartered Professional Engineer or ACPE since 2022, ASEAN engineer, professional electronics engineer since 2019, as well as professional electrical engineer since 2018. And for his professional affiliation, he is a member of IECEP Power Electronics Society, a governor of IECEP Oman chapter, vice chairman board of trustees in Philippine School of Oman, and chapter president in IIEE Sultanate of Oman chapter 2019, and lastly, a member of Kapisanan ng mga broadcaster ng Pilipinas. So let's give our hand of applause to Engineer Joel C. Aljona, PEE, PECE, AE, ACPE, FACPE. Let's give him a round of applause.
Thank you and good day to everyone. Malinaw ba ang voice ko?
Yes, loud and clear, Joel.
Okay, thank you. Let me share my screen.
Please share your screen. Zoom Master. Please.
Naka-allow na po.
Joel, you're already close. Please try.
Okay. Can you see my slides?
Yes, the slide is clear. Just put it in Zoom.
Okay.
Yes. We're still on the PowerPoint. Make it okay. Yes, go ahead now. Clear.
Okay, my topic for today is about power and data cables matter. Then without further detailing my profile, it was already introduced. Here are my previous and future technical seminars. And currently, I'm going to tackle on the power and data cables matter. And I have future seminars like the harmonics. I hope you can join on that soon to be. And here are the previous technical seminars and the future. The target participants actually for all practitioners under RA 7920, for electrical engineers and RA 9292 for ECE, as well as educators and students, and also for the government agencies and others. Here is the description. I will not go on that. Maybe you can review that during the viewing in the YouTube. And here are the objectives. Understand the significance of power and data cables in various systems until engaging in collaborative discussions. There are some points that I'm not going to cover because we have a time squeezed already, but minimal only. Here are the outlines that I'm going to cover. Question before I start. Ito yung question ko. During your design and implementation process, did you take into account all the relevant cable specifications to ensure optimal performance and reliability? Now, before you answer, you have to be honest. Just say A or select A, B, and C or C. So I want to put your answer in the chat box. Just be honest. And I will ask again after the seminar. So I need you to answer this. Very honest. I want to see your answer. Now, we can see from 1 to 10, hindi ko na bibilangin lahat. There's no need. I'll take from 1 to 10. The answer is, there is 1 no here, 2, 3, 4, 5, 6, 7, 8. So, obviously, makikita niyo na obviously this is an honest answer. Obviously, in design and implementation, most of us did not consider heavily on cables. Now, on this topic, on this webinar, you will change your perspective when it comes to cables. So, based on the answers, honest answers of the participants, I can see around 70% or 60% are not considering cables. Now, let me start with this matter. Power and data cables in various systems. Let me share my slide in full screen. We know already about cables, so there are actually two general distinction of cables. We have the power and data. Now, we attempted sometimes that we use data as power and we use power as data cable. Now, later on, you will realize if it is possible. The main purpose of the power and data cables, they serve distinct purposes, mainly to transmit power or data signals respectively. Power cables are used to transmit purely or mainly electrical power from one point to another within electrical systems. That is the main purpose. Like this in the picture. And you will know that we are all aware we use copper and aluminum. And usually they are insulated. There is a reason why it is insulated. Now, here is a question. What are the other known types of conductors? Anyone from the participants? Anyone? What are the other types? I already mentioned copper. Gold. Very good. So, yes. Based on the chemical element in chemistry, is if you recall, metals are the best conductors. So ito yung blue, mga blue. But primarily, copper, gold, and this is silver, gold, and aluminum are the, sorry, in Middle East, it's aluminum, but in Philippines, aluminum. Aluminum, and there are the other two, the palladium and the platinum. So these are the one I boxed it are the best conductors. So we have the silver, copper, gold, aluminum, platinum, and palladium. The question here is why we did not use gold and why we did not use platinum in our cables, mainly in cables. Why? So I need to know the reason. Yes, it's not only expensive. Try to put gold as a cable everywhere. You know what will happen. We know the reason. The only thing gold is used for micro designs like IC. Sa loob ng IC, alam natin gold ginagamit. So, also, sorry. May naka-mic? Okay. Also, we use also aluminum for other reasons. Like for the high tension power lines, we should use a lighter one. Dahil kapag gumamit tayo ng conductor na such as copper, mabigat kasi ito, so we need aluminum for lighter cables. And platinum, we cannot use this one because it's also expensive. Agree, magka-blackout pag gold. Actually, it's not really possible for the gold. So let me proceed for the next slide. And with their valence electrons respectively, silver, copper, gold have the same electrons. And for the aluminum, platinum and palladium, they are almost having the same number of electrons on the valence shell. What are the applications of the cables? Mainly it is electrical power distribution usage, industrial, you will find it everywhere, household electrical wiring, and outdoor applications. That's the main use of the power cables. How about the data cables? The data cables are used for transmitting digital data between devices and systems. Also, data cables is used also for transmitting or carrying analog signal representing data. So we can also use these data cables. And normally, if you look at the current cables, karamihan sa kanila twisted na. We know the reason. Bilang ICE, alam natin ang dahilan to remove interference, noise, crosstalk. Yun ang pinaka-main reason dyan. And data cables, what are the application? We have computer networking, telecommunications, audio and video connections, and we have also USB cables and so on. There are lots of cables we can name for the data, including the control system cables. And another type of cables, we have the hybrid. This is both power and data for the hybrid. So like for example, the PoE. The PoE is categorized under hybrid cables. So yan ang example niyan. And in the emerging technologies, there will be hybrid cables will come up. And here are the summary. And I have here the a part of the slide that I'm going to discuss. Kung may time, itatakol ko to. This is about the wired or cable. The other term for the wired, we call that one cable and wireless communication. And some say it's also categorized as fixed communication. We can call it wired or cable. So I will not go into that detail. So if may time, babalik ako dyan. Now, we have standard voltage levels for electrical power systems and equipment. Be aware, maraming standard voltage levels. The cables are categorized by voltages. Start with the standard from the international standard, IEC. And this is widely used all over the world. We have from extra low voltage up to extra high voltage. Now for the ELV, this is below 120 volts DC. These are categorized as ELV. The most common cables around, ito ang pinaka-common, especially in lower end, pinaka-common to. And we have also the American standard. We up to Philippine standard, we have this one. Philippine standard follow the same standard prescribed in the IEC. So makikita mo parehong-pareho in some categories. What are these standards? We have the international, US, UK, US, and we have another international, and the UL is a US standard and international. Now, awareness of the origin of the cables are very important because the categories are different. May mga diferensya yan. Next, we have the other standard. This is the standard of the New Zealand and Australia. We have the, what is this KSA? Anybody aware on this? This is Canadian standard. And if you are aware with GOST, this is a Russian standard. We have the Japanese standard. we have the European standard, we have the South Africa, and we have China, and we have India. And you have noticed that most of the cables in our country are locally produced. That question will be answered later. Why? Napapansin nyo na karamihang cables natin Pilipinas yan. You will see that. And why we don't have some from Japan, from Canada, because we have our own local certified cable products. Then take note that the voltage classification will vary from one standard to the other. So you have to go to the standard and you have to check the latest standard. Now, how about the telecommunication? In telecommunication, mostly, aware tayo lahat dyan, that we are dealing on ELV side. Ito yan. 120 volts below or 50 volts below, or typically 48 volts DC. These are very common. And we have also a game changer. What is that? Game changer is about the power electronics. Now, if you are starting to take the field of the power electronics, this is one of the emerging trends. Why? Because we will not only stay in this level. There will be changes of devices. We will soon be encountering not ordinary transistor, not ordinary diodes, not ordinary MOS devices. Later on, there will be variants of the diode, transistors, and MOS in terms of materials, because there are many discoveries that we can use another materials to support or to emerge the electronics. So the game changer of the technology is power electronics. So put this in your mind that power electronics will be one of the game changer in the industry. Not only telecommunication, not the others. Power electronics, take note on that. There also, why I'm saying this a game changer. There are many technologies that we are already embedded. Naka-embed na tayo in all sectors, including electrical power aspect. Naka-embed na yan. Now the question is, how are we going to have a share? Paano natin magkaroon tayo ng share? Strong presence, strong participation. If our advocacies are dormant, we will be overpass. Masasapawan tayo ng ibang industriya. Why? We are our specialization is embedded with other specialization. So how are we going to keep on the track? We should be active. We should be our strong presence in all sectors must be felt. Mararamdaman dapat. Dormant, there is no place for being dormant for this. So this is a game changer, really. Our future opportunities. Now, this is for the telecommunication. As I said, we will not be dealing purely one day in telecommunication like 48 volts. There will be areas, another voltage levels that we will be going to deal with. Why power and data cables are very significant in various systems? This is the question. These are the significance. Power transmission, data communication, reliable connectivity, efficiency and performance, safety, flexibility and adaptability, interoperability, scalability, automation and control, innovation and technology advancements. Nakikita nyo gaano ka-importante pala ang cable. It is part of the system. The cables are part of the system. The significance are very, very high. Makikita nyo ang numerous importance. Now, let us go to the general model, why this is very important or significant. As we know that if we are going to deliver power, and then it is expected to be received, but there is always a power loss. Don't forget. Now, if the system or the cables are not properly designed or implemented, it will go to the losses. Malaki ang loss yan. So, why we are particular on power? We need to have to consider the power is sent will be efficient to the power received. So consider the losses. Now, in the two bus diagram we have here, in every 2 points, the sending and receiving, between the two, you will face a loss parameters. We have the resistance and the reactances. So, dito mawawala itong loss. And this loss parameters, it is not just can contribute power loss. Marami yan. Isa-isahin natin yan, di tayo matapos sa class, sa seminar. So power loss is not just one consideration. Lahat na yan, masasali yan dito. Now, when you are dealing with a very small system to the large-scale system, ang una mong iisipin will be go back to the theory. The Thevenin, the Norton, and the maximum power transfer. I'm sure you studied this well. You stick to this concept with these 3 theorems, because no matter how big, how small, this is your approach when you are going to deal with the transfer of power. So I'm not going to discuss this. This is not a classroom. I'm just to review this one, just to go on detail. Now, why I'm going to show the 3 parameters here, because I mean the 3 theorems here, because these are the commonly or widely used approaches in analyzing from Thevenin down to maximum power transfer. And then, especially the maximum power transfer. And then, also the Mellman's theorem. Huwag niyo itong kalimutan ang Mellman's. Alam niyo ang Mellman's, you need this concept. It can be converted into a maximum power transfer. Yun din ang approach dyan. So magagamit mo rin yan. So these 4 theorems are widely used when it comes to higher applications, high-level applications, or even low-level. Next, about maximum power transfer, nakikita niyong picture dyan. Sino ang naka-benefit sa power transfer? The sending side or the load side? So nobody claim. Now let me elaborate this one about maximum power transfer. In maximum power transfer, if you are not aware with the consideration of the load, the maximum power you will get is 50%. Don't forget that one. When dealing with transferring power from the load to the source is 50%. So the power efficiency is only 50%. Now this is some of the designer forgot this kind of consideration, that 50% you will get Now, how to come up with greater 50%? So you go to this approach of the power efficiency. You have to look at the efficiency when you are going to consider the transfer of power. For example, we have the formula here. The load side over the power side or source side. Look at carefully when you are going to transfer power by considering the resistance. Ri is the internal resistance or from the sending side. This includes cables and the load side. If you make the internal resistance constant, and you are going, how are you going to improve the efficiency? This is on the load side. Look at carefully. When you make this one equal, you have 50% efficiency. But how to improve your power efficiency? We have here, you need to increase the load side resistance, the load resistance. You will notice here, if you approach to the infinity, you will have 100% power efficiency. But in reality, not all system can do this 100% in reality. Kaya mapapansin nyo, yung may mga calculation kayo na makikita kayo ng mga data sheet, efficiency is only 60%, 80%, because not all setup will provide you 100%. Now, what if you keep the load resistance constant and you increase the internal, the source resistance? Hindi magkaroon ng malaking significance yan. Mapupunta sa zero yan kapag pinalaki mo yung internal. So makikita mo dito na by looking into this graph, from here alone, very important consideration when you are going to look at the power transfer. Tulad dito, you have 50%, and then trying to make it making greater opposite with each other, tingnan mo ang difference. So this graph will be able you to understand the efficiency. What are the factors that can affect the power transfer? Okay, ano bang mga dahilan that can cause the power transfer problem? Ito lang. As an EC, you have studied this one. There are several factors you have to look into. We have the considering one section or the lamp circuit, this one section. The resistance is one parameter. Next, we have the inductance, another parameter. Capacitance and conductance. So in every cables, there is always, or there are factors that will be affecting the power transfer or data transfer because of this. Please, you have to look at the model parameter. We have the R, L, C, and G. I'm sure if you are a student or professional, you have been dealing with this, these parameters. For the resistance, this involves conductance, the physical construction or the geometry. How about the radiation? Yes, skin effect and the proximity effect. For the inductance, we have the permeability, the construction, how it is constructed, and also it contributes to skin effect, proximity, and radiation. So these are all the factors that can affect power transfer, including the voltage and the current. In the voltage, either you have the DC or AC, because AC has a frequency. Therefore, this everything changes when there's a frequency. Now, also, the last one is when you increase the length of the cable, ito ang babantayan mo. The moment you increase the cable, it also adds the factor. Don't forget. And in telecommunication or in data, one important factor you have to consider is the ZO, the Zords impedance or the characteristic impedance. And you are all aware on this. So generally, this is the model between the sending end and the receiving end. You have to introduce a cable which has a ZO that will match between the source and the load. So we call this one a transmission line, where it is complying or satisfying the characteristic impedance, where RL equals to ZO. So characteristic impedance, or if you look at the transmission line, the behavior of the transmission line is an equivalent. These are the lamp circuits, consists of capacitors, inductors, and resistors. All along the way, it will be viewed, this transmission line will be viewed like this, and simplified to be in this way. These are the lamp circuit equivalent of a transmission line. So here is the general formula of the characteristic impedance. Or most of the formula to calculate of the ZO is based on this, and the rest of the formulas, these are the formulas to deal on characteristic impedance. So this is one consideration or one important consideration in cables. Here are some specification. Normally, you are aware on this, you are familiar with these cables, like the rigid guard cables, the coaxial cables, this one. And there you will see the characteristic impedance specified, velocity factor. And you notice this one, it varies. Because the main reason is the material used for the insulation, the dielectric material. Yung insulator mismo is responsible for the dielectric. And it has respectively attenuation. And be aware of the voltage limit of every cable. Ito yung typical specification looking into the cables. Here are the summary of the factors that affects the power transfer. We have the distance, conductor size and material, voltage level. These are the things you have to one by one consider when you are dealing with the cables. Line impedance, load characteristics, power factor, yes, this affects everything. You have to consider this. Temperature, yes, frequency, and most of all, I am sure nobody thinking of environmental condition. Cables, when they are installed from one location to the other, will vary. There are consideration for that. Don't forget, hindi pareho ang cable na naka-underground, naka-aerial, hindi pareho ang mga consideration yan, magkakaiba yan. So, this includes the environmental condition. Until power quality. Cables are part of the power quality factor. Napakarami ang consideration when it comes to cables. Maybe you are thinking that cable lang yan. No. Cables are part of the system. Aanhin mo yung multi-million system mo, but you are forgetting consideration on cables. Walang kwenta ang multi-million mo na system. Cables are part of the system. This is for the power. Look at carefully for the electronics and the data. Malaki. Ito yung kailangan nating ipupush in many regulation. temperature and thermal management, AMI, electromagnetic interference, signal to noise ratio, bandwidth and data rate, signal propagation, power efficiency and battery life, latency, yes, latency is important also. Security and data protection, you have to consider already this one. There is a story, may balita na even fiber optic laid or submerged underwater or submarine cable. This is breach. Na-breach to, physically breach. Kaya security and data protection is also considered. Interoperability and basic standards. EMI and safety compliance. Napapansin niyo, kailangan ang compliance ng EMI. Semiconductor technology, RF propagation and antenna design, component reliability, and lifespan. Kailangan natin na isa ang cables ang pinakamalaking factor na mahaba ang service. The lifespan of the cables. Why? We can replace the equipment, but cables, we can keep it as long it is compliant. Fundamentals of power and data cables. Here are the fundamentals. You have to look at the conductors, insulation, the rating. These are important when you are going to design. Ito yung mga consideration mo. Fundamental consideration, conductors, insulation, voltage rating, current capacity, cable sizing, armor, and the type of jacket. Ito yung mga pagpipilian mo. Now, the question is, mahal. Actually, ito yung una nating pumapasok sa isip, mahal. But when you are going to consider the reliability, long-term use, bawing-bawi. So, when it comes to reliability, huwag mong iisipin kung mahal ba ang cable o hindi. Consider all of this, especially kung ang isang system is a high-end, i-consider mo to siya. Also for the data, mostly our cables are twisted, then we have the shielding, and it is in category rating. We have already, currently we are using category 6, then there are 6, 8, then 7, 8, 9 on the way. Paparating na ang 7, 8, 9, nandyan na. So consider the category data transfer rate, titingnan mo rin yan. And the standard, termination, and fiber optic cables. By the way, aanhin ang mataas ang data rate ng isang system but ang cable bagsak sa data rate. Wala din kwenta. Therefore, ang cable should comply sa data rate ng system. So, masasayang lang yung, when it comes to techno-commercial or in a commercial perspective, masasayang lang yung system na maganda ang rate pero bagsak sa rate ng cable. So, titingnan mo rin yung rate ng cable dahil these are tested. Okay? And data, power and data cable selection. How to select? Dito na tayo. Paano ka select ng cable? Let us go first with the power. Number one factor is the current rating. Titingnan mo ang current rating ng cable, then voltage, the material use, insulation type, environment. Now, napapansin mo ulit dito na may environment. Di mawawala yan. Because you are going to put the cables in the facility. So mag-iiba yan. Mechanical strength and fire performance. Okay, these are the factors. Let me go next. I'm taking a good example of a power cable. Familiar nyo to for those who are dealing with power cables. The THHN cables. This is a general purpose. Usually ginamit to sa residential, commercial, and industrial. At naka-conduit ito or naka-raceway. The good thing of the THHN is a very high heat resistance among other cables. Now, what is a THHN cables? Ito yung meaning ng THHN. Thermoplastic high heat resistant nylon coated cable. So ito yung mga ibig sabihin yan. So be aware of the code, cable code, dahil may mga ibig sabihin yan, not just by the current rating, you have to be aware on the specification. Now, what is a THHN? Makikita mo, ito yung example ng THHN. The THHN has a 90 degrees Celsius. Now, ano yung mga naka-install sa mga bahay nyo? Now, if you are not aware, most of the installation of cables sa Pilipinas is TW. Nasa 60 degrees lang yan. Mababa ang temperature dyan. Unlike THHN is 90 degrees. So, sasabihin, nakamura ako ng kable. Ang THN is, for example, let's say 100 per meter ang THN. Ang TW, let's say 50 pesos. Sa market, binibinta yan 50 and 100. Pumili ka ng cable, dahil 50 mura, you are happy, but you are not aware the specification. Magkakaiba ang pricing when it comes to cables. The more expensive, the more quality yan. Kaya sometimes, be aware na huwag kang maghanap palagi ng mura. Dahil mapamamura ka talaga dyan, to be honest. You have to consider also the quality. So this is the THHN. Look at carefully the standard of the THHN. Makikita mo ang THHN standard is a Philippine national standard. Ibig sabihin, meron tayong local products dito. We have the national or local. At pumasa ito sa international, yung underwriters. Ibig sabihin na preference natin ang local standard because it complies with the national international standard. And there are variation of sizes, meron tayo niyan. An application, makikita mo saan ginamit. Ito yung paano ka mag-cable select. Titingnan mo ang specification ng every cable. Then, standard colors. Ito yung colors available only. Walang complete color yan. Standard din yan. Sinusunod ang standard. And lastly, how it is certified. Kung titingnan mo ang certification yan, merong national at local BPS, Bureau of Product Standard. Ibig sabihin, ito compliant ito sa Philippine standard. So ito yung una mong titingnan, meron bang local standard o local compliant? And then if there is none, you go to the international. And when you go to the international, see to it na naka-align sa standard ng Pilipinas. Dahil kapag hindi ito align, magkakaiba yan. Malaki ang pagkakaiba. May impact yan. I already discussed earlier several factors on that. Okay, next. Here are the specification of the THHN. Kinuha ko lang ang isang cable. Actually, marami yan. Under UL83, ito yung mga specification. Kapag THHN, naka-standard yan, pareho na yan lahat, whatever model is that, pareho yan, complied lahat yan. Look at carefully the standards here, all complied. And here is also the other factor of cable selection. Ito kinuha to sa Philippine Electrical Code. Now, look at carefully the TW, 60 degrees lang. Mostly TW ang ini-install sa mga bahay-bahayan. At look at the THHN, nandito yung THHN. Nandito, 90 degrees. At ito yung, ngayon, Bakit THHN? Iba ang current capacity ng THHN. I-compare mo yung current niya versus the TW. 15 lang at 25. Now, magtataka ka, bakit maraming sunog sa Pilipinas? Alam mo na, from the cable alone, alam mo na, malaki ang difference ng THHN at TW. Malaki ang difference yan. Very significant. Kaya, this is very important in cable selection. Current pa lang to at temperature, there are others. So I box this one to emphasize the 90 degrees. We have the national and local on this. And ito yung specification ng THHN ng Philippine Standard. Ito yun. Makikita mo yung specification ng TW, ang until THWN, PNS, at yan, ito lahat. Paano mo malaman na mayroong compliant ito sa Philippine Standard? Makikita mo yung PNS at Enabling Law, DEO 2207. Ito yung babantayan nyo palagi. If there is a Philippine compliance or certification. Okay? And then, ito yun. Kukunin natin ang example na size ng marami dito ang installation, practice of installation. I will take the 2 square millimeter with the capacity of 25 amperes. Ito yung ampacity or capacity. Now, during termination, naputol 7 by 0.6 millimeter. Anong ibig sabihin ng 7 by? Anong ibig sabihin ng 7 by? Sa mga participants, ano ang ibig sabihin ng 7 dito? Any help? Okay, 7 strands. Ngayon, look at carefully. Sa mga nag-install ng kable, kapag maputol mong isang strand, what will happen to the ampacity? Malaki impact yan. So be careful also in termination. Dahil 7 lang yan, kapag maputol mong isa dyan, malaki ng epekto yan sa ampacity. Kaya best practices are always observed. Hindi ka pwede pumutol, hindi ka pwede yan magasgasan mo yan, ingatan mo yan. Kaya there is a proper practice on termination. Ito lang, pinakita ko lang sa inyo ang stranded type dahil maputol lang isa yan, malaki ng epekto yan lahat. Okay? Ito yung sa solar. Ang solar standard, meron tayo sa Pilipinas. Makikita yan. Solar cable. Meron tayong international. I'm sure sa mga installer or mga designer ng solar, you are aware already on this. Meron tayo, so far, unfortunately, wala tayong Philippine standard. Nakikita mo dito, puro yan international. So, what cables in preference na kukunin mo? The international standard under this specification. Now, if you are going to use other type of solar PV cables, without this consideration, risk or other factors may be, we call this one, disrupted, maapektuhan ang factors yan. Look at carefully the standards of the cable. Wala tayo sa Pilipinas as I check. And how do you know how to cross-check the sizes of the conductor versus between millimeter square and American wire gauge? Ito yung mga comparison. Yung gumamit ka ng pang-electrical wiring, ito yon number 14. Ito yung number 14, electrical wiring for the lighting. So ito yung 2 mm squared sa mm squared. Iba to sa British standard. Sa British standard, ang ginamit nila is 2.5 mm squared. That is why, be careful, kung gumamit ka ng American standard, you have to use the American standard. Dahil magkakaiba kasi yan eh. If you use cables from the British, malaki na ang difference yan. You have to be careful also. Now, Another factor of cable selection, yung mga nag-i-install, dealing on instrumentation, may mga motors, ito yung kumpletong design ng isang motor. Hindi lang motor tapos isaksak mo agad sa power sa mains. No. There are standards on properly designing the motors. So kung gusto mong ma-obtain ang full information nito, you can go to the Philippine Electrical Code. Ito yung hierarchy or levels of design mula sa there are two between power and control cables. And power, it must be protected. Control cables must be also protected. Now, if those who are not aware on the motor control, normally, ito yung motor control. Meron tayong power side. Ito yung power side. Ito yung motor. At ito yung control side. The cables used in the control cables are different with the power cables. Magkakaiba yan. So, this is to everyone's knowledge. Kung hindi aware sila sa motor, there are two categories dyan ng cables. There is a control cable and there is a power cable. So, typically, British standard, they use 1.5 mm squared for the control cables. For the power cable, magdepende sa size ng motor. So, hindi pareho yan. At hindi makapareho. Even protection, hindi makapareho yan. Especially sa Pilipinas, hindi makapareho ang design yan. Magkakaiba yan. Okay? So, hindi dealing with the motors, if you are buying a motor at saksakan lang, you have a big problem on that. No protection from all parameters. Kung motor lang at saksakan, that is not a good practice, a good installation. Okay? So let me go next. Now, another consideration in power cable selection is the voltage drop. Kung bumili ka ng cable, ang another titingnan mo is the voltage drop. Now, in the electrical system, mula sa substation, mula sa transformer, until the load side, pinakalas, ito yung distribution board, meron niyang tinatawag na voltage drop standard. Normally, 5% yan. Ngayon, saan ang equipment side? Dahil ito siya, electrical side to. Ito yung design ng electrical side. The design on the electrical side is highly considered. Mataas ang consideration including the voltage drop. Now, the problem lies here, yung sa load side na. Yung mula sa saksakan, yung doon sa saksakan to the load. Ito yung question dito. Kaano kahaba ang pwede? Now, take note that 5% lang yan. Now, imagine, isang load lang to. Now, if there are hundreds of electronic system without consideration of voltage drop, malaking epekto yan, malaking factor yan. So, how are you going to be aware of the voltage drop? You have to, VD, you have to look at the calculation or the formula. Ito yung formula niyan. Voltage drop is the specification of the cable in millivolts per ampere per meter. Ito yun. Current. And then the length of the cable and the number of runs. Ilang kable. Ito yung pag-count ng voltage drop. Or you can also determine the millivolts per ampere per meter sa isang cable. Now, I use the calculator here. Now, I have a design of a certain load. Ang demand niya is 33.97 amperes. Now, how I'm going to determine, for example, this is to determine the voltage drop for the L. Ito yun. Example, I am aware that this is 5%. Now the question is, if I have a 45 meters length of the cables, what will be the percent voltage drop for the three-phase? That's 94%. Kahit single phase, 94%, 0.94 or approximately 1%. Now, you have a 45 meters. This is the question. Ang question dito is 1% already significant kung ito ay nasa L, ito? Yes. Why? Because kung 1% ito, lalampas siya sa 5% consideration. So nakikita nyo na as practitioner, mag-iingat kayo sa pagpahaba ng kable from the distribution, from yung saksakan, tapos pahabain nyo pa, mag-iingat kayo dyan dahil kapag aabot ng 1% or more than 5%, it will be a contributing factor of the voltage drop. And what are the effects of the voltage drop? Marami. Later on, ilalahad ko dyan. Marami yan. Okay. Going back to the L, ito yung mga nag-install, installer, designer, outside electrical design, you have to be careful on the L. Dahil you will alter the original design na 5%. Mostly 5%. British, Philippine standard, usually 5% yan. I'm not sure with the other standard, but mostly 5%. How about this 2.5 and ito? This is also a local standard by a certain country. At ito, local standard to like in Oman, meron silang standard 2.5%. Ito, how about the 1, 1, and 0.5? Kami na ang mag-determine as long it will keep 2.5. Ito yung electrical aspect ng voltage drop. So, mula sa substation hanggang sa loads dito, it must be 5%. Malaki ang epekto yan. Why? Sa Pilipinas, you have a nominal voltage of 230, then plus and minus 10%, then without considering the voltage drop, it affects everything. Nominal voltage in the Philippines is 230. May plus and minus yan. Hindi pwedeng sobrang plus, sobrang minus, may threshold level yan. You should be aware on the threshold level when the voltage mains are fluctuating from up and down, may threshold level. Maapektuhan, especially kung bagsak sa voltage drop ang mga cables. So, very important. Now, you go to the specification of the cable. Meron tayong specification dealing with the voltage drop. Meron yan. I took the specification from the Oman cables. Why? Oman cables are widely used in the Middle East, all Middle East, because maganda ang quality. This is based on British standard. Hindi ito magamit sa Pilipinas because magamit, but you have to be aware on the specification. Now, looking into the number 16, ito yung 16 mm squared. Ito yung MB niya, millivolts per ampere per meter. Ito yung kukunin mo na data in calculating for the voltage drop. Ito yun. Binabandayan to siya. For every cable. Imagine, every cable, isa-isahin mo yan eh. Kung merong 100 variation of cables, isa-isahin mo yan lahat. Hindi pwedeng i-generic mo yan. You have to make sure na voltage drop is satisfied. So, here are the effects kung bagsak sa voltage drop ang mga kable. If the voltage drop is on the level, nasa acceptable level, it will maintain the voltage level, avoiding overheating. Malaking factor sa overheating yan. And then efficiency is affected and energy conservation. Malaki ang epekto sa energy conservation. Kaya ito kasali yan, and compliance also with the standard. Performance of electrical equipment will be also affected. Power transmission will be affected. Circuit design will be affected. Lighting design will be affected. Bakit? Bakit pala sa lighting affected? May makakapansin dyan na bakit itong isang area dito maliwanag? Bakit itong isa hindi? Yan ang epekto yan. Yan ang mga palatandaan. Kailangan pareho. I'm sure yung mga nagde-design ng lighting, kahit maliit lang yung LED, mapapansin mo yan kapag hindi pareho ang voltage. Magkakaiba ang display ng LED. Pareho yan dito. Then it will also affect the low voltage system from the source side. Maapektuhan yan. And the renewable energy systems will also be affected. Now, voltage drop is also one important consideration in the design when it comes to cables. Ito yung calculation for the, we are done with the voltage drop. Now, another thing to look into is the capacity of the cable, the current carrying capacity or the ampacity. May limit yan. May limitation. Hindi pwede 100% ang kuryente ilalagay. You will always have a tolerance or allowable. So it is always less. And if you look at the formula, ito yung current, full load current, ito yung IT, yung sa tabulated current. There are other considerations when it comes to calculate the current carrying. Magdepende yan sa sa apat na coefficients. Environmental yan. Ambient temperature, grouping, thermal, and the protection. Anong klaseng protection anong ginamit mo? Now here, you cannot all the time use generic calculation for the cable when it comes to protection and current carrying capacity. There are other factors to consider, especially environmental. Therefore, this will make you aware that ang cable na cable tray will not be the same cable consideration kung ito'y naka-underground. Magkakaiba yan. Kaya because of this calculation and protection. And here are I took this data sheet from the Oman cables again about the current carrying capacity. Again, I'm going to take the 10 mm squared. Look at carefully. Ito yung voltage, anong voltage level category siya? 6. We have here, ang voltage category is either 0.6 to 1 kilovolts. Ito yung low voltage. And the resistance for the two core, dalawang conductor, 6 ohms. Ito yung mga example na specification for a 10 mm squared cable. Ito yung titingnan mo, especially for the resistance, DC resistance. Meron din reactance. From the beginning, I mentioned about resistance and reactance. Ito na yon. Titingnan mo to siya. Okay. Puro cables ang napag-usapan natin. Paano naman ang connectors? Another thing you have to consider connectors. Kung ang connectors, kung ang cable mo maganda, connectors are not, useless din yan. So this yellow here are connectors. Ito yun. You have to consider gender, then all the characteristics. Now, napag-usapan natin ang gender, masasabi natin na unfair ang engineering dahil dalawa lang ang gender dito, male and female. Paano naman ang LGBTQRZ? Ano ba yun? LGBTQ. Walang gender dito sa LGBTQ. So, based on this, dalawa lang gender, the male and the female. So, pag male, kailangan mo ng female. So, another selection is to look at the gender, male or female. This is between the 2 points and the characteristics. You have to look at it. Now, the connectors must be, the specification of the connectors must be greater or similar to the cables. Mas mataas ang specification than the connectors. I mean the cables, than lower. Bakit? Okay. Let me give you an example here. Ano kayang problema dito? Power cable to under power ha? Anong problema to? Anybody? Napag-usapan nating gender kanina. Ngayon, sabihin niyo sa akin, anong problema dito? Tama ng pagka-install pero make your opinion. What's the problem here? Undersize ang connector? Yes, hindi agree ako dyan. Termination, yes. Makikita mo. Again, ang male-female, pag male, i-ano siya niyang female. Pero ang nangyari dito, merong dalawang kable, merong ang halos tatlo na dito. Hindi pwede yan. Parang tusam. One-on-one. Parang nakatusam. Hindi pwedeng ganyan. It will not be accepted. That agree ako ni Sir MP, violation agad. Kaya Sir Russell, termination, yes. Bagsak ito sa termination. Sa termination, kung sinong nag-install nito, it is not, hindi pasado ito, bagsak na ito agad. Nahalata na, umiinit na dito. By visual inspection, wala na to, umiinit na, nakikita mo na, nangingitim. That's a sign. Indiano. Kaya, from the beginning, just a simple termination, malaki na ang epekto sa lahat. Based on my experience, a single loose connection lang sa isang kable, malaki ng epekto sa lahat. Sunog. Marami na akong naikwentro na ganyan na yung maluwag na termination. Meron akong isang instance na yung nag-i-inspect ako, isa sa inspection ko is hila pulling. Nagalit yung installer dahil bakit hinila ko daw? This is to ensure na pumasa siya sa attention. Dahil marami kasing pagkakataon na ano lang, light lang pagka-terminate. You have to check also kung hindi ba natatanggal na kunting tension mo. That is another way to check. Hindi lang maganda ito. Okay siya, magandang pagka-terminate. But you have to check kung talagang na-terminate ng maayos. You have to check na hila. Otherwise, you have to check how many tension or torque i-apply mo dito. Meron din yan. Para malaman mo hanggang saan mo siya i-apply. The number of torque or force applied. Meron yan. Okay. With regards to connector selection, merong gumamit tayo ng spade or ganito, yes. But according to the cables. Kapag ang cable mo is 10 amperes, this must be 10 amperes or a little higher. Kailangan malaki ito, not lower. Why? Kung ang cable mo is 10 amperes, ang connector mo is 5 amperes, alam mo na ang mangyari. Ito, magbabagayan. Umiinit to. Isa yan sa cause ang sunog. Yung without consideration of the connector specification. Then another one, this one. Kapag ito is 25 amperes, ito 25. Ensure that this is also designed for 25 amperes. Yan ang example. Ito yung mga joining. This is not all the time a good practice. Hindi ito siya recommended. Not at all times, but for maintenance reason or other reason, ina-allow ito siya. But not at all case, iiwasan itong mga in the middle of termination. Now, anybody tried, be honest, may mga gumagawa ng termination na ganito? Be honest. Lahat, honest tayo ngayon, may nagti-terminate ba ng ganito? Kung merong nagti-terminate na ito, do not do it. Especially kung aircon ang ano mo aircon ang load. Masusunog yan. Ganitong klaseng termination. Just a simple coil lang, isang turn na i-coil mo, heat will happen. Nangyari yan I saw a lot of times na ganitong klaseng termination, masusunog yan, especially aircon. Isang turn lang na tinorn mo yung kable, heat will occur. Magkaroon ng heat yan. Next, a simple selection or a single mistake of connector and cable, ito ang mangyari. Dahil lang sa cable at connector, maaring ito ang posibleng mangyayari. So I hope that we need to avoid that kind of mentality na naghahanap tayo ng mura. So for the data, ito yung sa data naman. Data transfer rate, category, ito yung mga factors to consider until it must be for future expansion. Again, environmental is considered. Kailangan i-consider mo yan. Connector compatibility and the distance. Another consideration is the distance. Now, looking into the data cables, for example, ito, you are very familiar with this. This is a Cat6 cable. Look at the specification. We don't have a Philippine standard. We base on ANSI, American standard. So ito yung standard, international. And then, certification is with the UL certification. Ito yung example na selection. You have to check the standard kung saan ang galing. And then, you are familiar with this para sa mga telephone cables, telephone company, ito yung mga typical cable. Ito yun. We have a Philippine standard on this, PLDT. This is a de facto standard or guidelines from the standard or the guidelines based on PLDT. So matagal nang ginagawa ng PLDT ito. So based on PLDT and RIA standard. And this is also used, can be aerial or duct installation. Ito yun. Here is also for the telephone drop wires. Ito yun. We have also a de facto standard. So, meron tayo for the Philippines. And the temperature here is 75 degrees Celsius. So, until 75 degrees Celsius. And for the FDAS cables, fire. What do we have a standard, Philippine standard? We don't have, only international standard. And yes, we have Philippine national standard for the FDAS cable. And we have also regional standard. So these are the cables you are going to select by looking on the specification. Next, we have the coaxial cable. This is a Heliax cable. I am taking an example. You have to look at the characteristics, electrical, impedance, characteristic impedance, frequency, power. Ito yung mga titingnan mo. And also, mechanical consideration and ito yun, frequency. So this kind of cable can handle up to 8.8 gigahertz. So what will be the suitable connector for this kind of cable? Gagamit tayo ng, ano kayang cable na gagamitin natin? Anybody? Sa mga ECE, if you see that kind of cable, what particular cable connector use? PNC, for this diameter, hindi na natin magamit ang BNC. We will use the N-type. This is N-type connector. So, mostly N-type for that kind of cable. Ginagamit yan N-type. So this is the specification of the N-type. And look at the specification of M-type up to 18 GHz. So nakikita mo yung range niya up to 18 GHz. Mataas pa sa kable. And then also the N-type is a military standard. Satisfying the military standard, mataas ang specification ng N-type. And here are the electrical specification. We have the impedance, yes, 50. Frequency range, see, 11 gigahertz. Ang coaxial na helix is 8.8. So, mataas siya. And look at the environmental consideration, military standard. Ibig sabihin, mataas ang standard niya nito when it comes to environmental consideration. And also military standard for this type of connector. So napapansin mo, N-type is widely used sa broadcasting, sa telecommunication, especially sa radio, sa GSM. Makikita mo yan sa mga connecting antennas. Now, how about the data cable selection when it comes to connector? Again, between points A and B, we have the gender. When it comes to gender, kailangan may matching din yan, impedance matching. What kind of mode or configuration? Is it balance, unbalanced? Meron kasi tayong grounded or ungrounded. Kaya balance or unbalanced. Characteristic, electrical, mechanical, and environmental again. Okay? Now here is a question. Why is it necessary to initially take into account the regulation, compliance, and certifications at both the national and local levels? Ito yung katanungan, bakit unahin natin why we have to consider the local regulation, certification, and compliance? Anybody can answer sa participants? Yes, agree. Legal. Correct, safety. Legal claims, safety. What else? Yes, agree, reliability. Again, environmental. Liability, lahat to, maintenance, agree ako dyan lahat. Lahat kayo tama. EHJ, yes. Availability. Agree ako lahat yan. So, in summary, wala akong nalagay na summary, but all of that is correct. Now, I checked the BPS, Bureau Product Standard. Maraming electronics products na wala pang BPS compliance or certification. What I found, merong electric fan, flat iron, meron ng mga PNS yan. Ibig sabihin, there is a local regulation or compliance na yan. And then you can check on this in the BPS under mandatory certification. Ibig sabihin, mandatory, required. May ibig sabihin yan. So, kapag electric fan, mandatory yan. Dadaan sa BPS. I did not include all dahil marami, pero after I check, kunti lang ang sa bihira lang sa electronics. But sa telecommunication, meron marami sa NTC, marami type approved, including computers, laptop, nandun yun, nakita ko. Next. Unfortunately, again, for related sa cable selection, ang available standard sa Pilipinas is related sa nuclear. This one, nuclear connectors, ginagamit sa nuclear. Wala pa tayong nuclear energy. So you have coaxial connectors for nuclear. I check, this is about cables. I check for the coaxial, ito lang ang available related sa nuclear. And then, Don't forget to consider in cable selection environmental factors. Number one ito. Number one, every place is magkakaiba ang environment. So there are many consideration. Lahat dito naka-indicate. Lahat 2, 4, 6, 8. General, climatic, external, mechanical, ergonomic, lahat yan kasali. And mainly consists of that is ambient and created, yung tinatawag na incidental or ginawa. And the other is how it is operated on where. Ito yun. Kaya marami kang consideration sa environmental. And dalawa yan, situation and conditions. So start with the basic conditions. Ito lahat, climatic, externally generated influences, marami mechanical, vibration, and shock. Kasali, terribly ang environmental condition. Ergonomics, meron. Including the health of the engineer, kasali yan. Wala. Electrical, AMC and EMI. Kapag environmental, kasali talaga ang EMC at EMI. Under electrical, chemical, meron. Biological and general. Under conditions, environment, kanina is basic, ito naman ang conditions. Operational, storage, and transportation. Take note also na handling of equipment and materials, handling is also considered. So, pagka-transport pa lang ng materials, it must be complied na hindi magbabago ang specification ng kable. Kaya meron ding factor ang transportation. I have experience yan na sa handling. Yung sa factory, yung mechanical construction niya, nung i-deliver, nagkabaliko-baliko na. So there is a problem on that, especially sa transportation. You have to consider how it is transported. Don't forget that one. What are best practices? Tama ba ito? Question ko, is this correct? Is this the best practice? Tama ba yan? Yes. This is not the best practice. So what are those best practices? Start with the power and data cable installation. Ito yung mga best practices. Plan and design. Use recommended cable types. And bend radius. There is a limit of radius bending. It should not go less than 90 degrees usually. Pero maraming mga situation na less than 90 degrees. So be careful on that. Support and secure cables. Separate from electrical sources. Yes, always separate. Labeling. Avoid sharp edges. Avoid tension. Number one, tension. Bakit kaya? Bakit i-avoid natin ang tension? What's the reason? Ano kayang reason why cable stress? Correct. Data loss? Yes. Why? If you are going to put a lot of tension sa cable, ang magbabago is ang characteristic impedance. Automatic, yung ZO maapektuhan. Agree. Don't forget, ZO will be affected. Automatic yan. Aside sa stress and other factors. Yun ang reason yan. Kaya mag-ingat kayo, may limit sa pagtitension ng kable. As much as possible, huwag mong ma-deteriorate or ma-disrupt yung characteristic impedance ng kable. The cables are designed according to the ZO. So if you put a lot of tension, magbabago yung orientation or physical properties ng cable. Kaya maapektuhan yung characteristics niya. That is the main reason. Next, installation. That was installation. How about the termination? Quality connectors. Kasali ang crimping. Kailangan you are doing the correct crimping and soldering. May tamang soldering at crimping. You have to maintain the twist as much as possible. Merong mga practices na kinakalimutan ito. Then the insulation displacement connectors, the IDC, you are going to apply IDCs always. Testing, you have to do testing. Ito yung example. Ano bang nangyari dito? What happened to this? Is this correct? I'm sure I have seen a lot of this. Maraming gumagawa ng ganito. What happened? Yes. The twisting is already, yung twisting pa lang, malaki ang untwisted. It can affect already. Ito is, this one is already malpractice. Okay, now continue. How about grounding? Proper grounding must be, why grounding is part of the best practices. You have to consider the best grounding as much as possible. Then grounding conductors, bonding, and equipotential grounding. You have to consider the best grounding practices. And how are you going to base on that? I have here a typical grounding approach based on the TIA standard. So ito yung mga typical grounding practices based on telecommunication standard. Okay? So don't forget to apply grounding. Next, cable termination. I mean cable management. Routing must be observed. Cable management solutions must be adapted. Proper labeling and documentation. Consider the cabling. Regular inspection. Palagi. So, what happened here? So, tingnan nyo maigi. What went wrong? On the left side, this is not recommended. On the right side, this is one of the best practice. Kahit tinanggal mo na yan, kailangan ibalik mo sa original as much as possible. Before and after. Yes, this is before and this is after. Yung spaghetti, after na siguro yan. Agree. Okay, so now next are what are the potential interactions and interference between power and data cables? Marami yan. Maraming potential interference and interaction including EMI, RFI, crosstalk, voltage fluctuation, ground loops, common mode noise, rejected noise, and shielding interference. Mitigation on the right, cable separation, twisted pair cable, shielding, grounding. Ito yung mga mitigation. Balance power distribution, ferrite beads, separate grounding path. Yan. Yan ang mga problem and mitigations. So be aware on this. Hindi pwedeng magkatabi palagi ang power at data. Hindi pwedeng magkatabi yan. Here are the typical example of distance between data and cable. separation distance. For this example, we have 1 mm squared. Total number of power cables, ang separation distance is 0.004 meter or 0.16 inches. This is an example of separation. Another here, next slide. Ito yun. Look at carefully the separation. One of the typical separation between data and power. This is the power and this is the data. This is 0.6 of a meter. Take note that there is a standard separation for that. Ang ibig sabihin dito, hindi mo pwedeng ipagtabi ang power at data. Don't forget that one. Take note. This is the typical setup. Meron dito 0.3 or 1 foot separation. For the armored, magdepende kasi sa material or type of cables. Next, there is look at carefully another one. How to separate cables. This is not recommended. This is very, very bad. Not recommended. This is correct separation. But look at carefully how, what is the best separation? Ito. Magkahiwalay lahat yan. Power, auxiliary, IT, and sensitive circuits. Makikita mo ito sa mga mall. Kung sisilipin mo yung mall, when you look up high, makikita mong cable tree ng power, hiwalay yung GSM, hiwalay yung IT, hiwalay yung auxiliary, hiwalay yung other circuits. Ito yung standard, best practice. Now, there's a question. Is there a separation between power cables and FOC? Anong answer kaya? Yes. The answer is yes. Kahit fiber optic yan, also you have to separate. The FOC must be also away from power cables. Don't forget. Next. I think this is, naulit lang to. Cable maintenance, testing, maintenance, and troubleshooting. In testing, there are many tests to be done. Continuity test, you have to do that. Insulation resistance testing, you have to do that. Don't forget, maraming nag-install na hindi ginagawa ito. Especially sa mga data cables, even power. Voltage testing, check nyo rin, and data transmission testing, merong, and cable certification. You have to check all of this. By the way, data transmission testing, merong mga equipment ito specific for data transmission testing. Meron yan. Mga transmission engineers, they know that one. Like the BER testing, meron yan. Protocol testing, meron yan. Kasali yan sa cable testing. Even the ping, yung normal na ping, kasali din yan. How about the maintenance? Regular inspection. You have to do regular inspection. Hindi yung nakabenta or naka-install, after that, wala na. You have to tell the client, you have to recommend to the client that there will be a regular maintenance. So, syempre, pag may regular maintenance, there is a fee. Emphasize yan, especially yung mga high-end system. Cleaning, retesting, environmental monitoring, and cable identification. Kasali yan. Next, cable troubleshooting. The first step in troubleshooting is visual. Visual. Now, for me, in my practice, either power or data, when it comes to power, i-check ko muna ang main, the three-phase, the voltage, i-check ko lahat yan. Record before doing maintenance. Then after doing the maintenance, i-record all documented yan. That is the best practice. You have to do that one. In between, before and after, you have to do checking para to certify na to certify you have approved na walang nabago, walang significant change, wala. Para ano mo yan, maganda yan na practice. At another thing, why? Based sa experience ko, if because I'm doing like that, ma-predict ko na what is the problem ahead. May nagre-report sa akin na ganito ang problema. Alam ko na, ma-visualize ko na. Hindi ko pa napuntahan ang site, nabivisualize ko na ang problema. Dahil alam mo na if you are familiar with the setup, you will know saan mo titirahin. So, visual inspection, you have to do that. Then testing equipment, cable tracing, ping, yes, it is here. Nandito yung ping and connectivity test. Sa ping pa lang, malalaman mo kung gaano ka yung latency ng transmission, makikita mo dyan yung latency in milliseconds. One factor is the distance, also the cables. Makikita mo yan sa ping pa lang. Replacing faulty components, eliminating source of interference. Ito yung mga troubleshooting. Next is importance of safety compliance in handling power and data cables. What are the importance of safety? Ito yung lahat. Personal safety, yes. I remember before may nasa broadcasting ako. Another broadcasting station, may namatay na technician. Why? Ito yun, personal safety. Bago siyang ligo at pumunta siya sa likod ng transmitter at nakurinti. So, personnel safety is a concern. So, each professional, each practitioner must be aware of personal safety. Always observe safety at all times. Hindi yung wag isipin natin na magaling tayo. No. Safety first is always number 1 yan. Fire prevention. Because of the fire prevention, compliance yan, data integrity, equipment protection, regulatory compliance, system reliability, risk mitigation, avoiding EMI, ito another one. Environmental safety and long-term cost savings. Ito ang one main reason bakit you have to be compliant. Long-term, ito, marami. Marami talagang importance ang compliance in handling. Again, makikita mo yung before and after, or actually it's not, maybe from the beginning, ito na ang installation. Okay. Here is another one. Where is the risk? May termination dito. Can you identify saan dito ang risk? This can cause sunog kapag hindi properly installed. Aside sa exposed wire, merong pinakamataas na risk. I agree, exposed wire. Yung termination na lang, bagsak pa. Bending, it could be, pero merong isa. Identify the risk. Yes, short circuit. Nakahalo ang live, yung brown wire. Live yan to the ground wires. Kapag hindi ito protected to the load side, kapag ang kable is hindi siya fire redundant, sunog ang mangyari dyan. Kapag walang protection ito. So, the risk is this one. Ito, another risk, pero pinakamataas ito. Dahil it can cause fire ito, dahil brown wire yan It means live wire yan Another, okay, I'm sure any one of you are still doing this. Let's be honest. Iwasan nyo to dahil this will be the future risk. Magiging future risk ito. Either power cable or telecom cable, iiwasan ang mga ganitong practice. Hindi ito nakikita, usually nasa roof kasi ito Ang client, tuwang-tuwa dahil gumagana na yung bahay, umilaw, umandar ng AC, pero no idea how it is installed sa taas. So ito yung sa roof. Actually, hindi dapat ito i-practice. So you can check in your rooftop. Sa loob ng rooftop, ito ang makikita nyo. Actually, yes, it is true. Ito yun. Hindi yan maitatago. But you have to, this is a risk already. Then we are almost over. Emerging technologies and future trends in power and data cable systems. Ito lahat yun. Hindi ko na isa-isahin i-define, but you can go back with that. Anyway, the slides will be shared. High-speed data transmission, yes. Fiber optic advancement, yes. POA will become evolutionized. Energy efficiency, nararamdaman natin na ang energy efficiency is already mandatory. Kaya you have to be aware on energy efficiency. Smart cables, we will be having cables na smart. Biodegradable and eco-friendly materials, multi-gigabit Ethernet, category 8, 9, 10 on the way, paparating na yan. Power management and control, there will be systems designed for power. Actually, meron na. Meron na to. Not in popular sa Pilipinas, pero meron na to. Power management and control. Wireless power transmission, yes, on the way. Increased automation and robotics, yes, these are emerging trends. Cable miniaturization, lumiliit na ang mga kable. Why? Because of the new components, new changes of components or material used for electronics. Magkakaroon ng pagbabago na lahat yan. Augmented and virtual reality cables, 5G infrastructure, 5G and 6G, enhanced cable management solution. Itong meron ng mga kable na hindi na kailangan yung balance and balance, automatic, smart na kasi. So within enhanced cable management solution, ito na ang siya na mag-determine ng characteristic, impedance, siya na mag-determine ng specification, intelligent, parang ganun. Darating ang time na we will have smart cables. Okay. And I will not elaborate on this real world case studies. The time is not enough, is not sufficient. And then I will ask a question again. Answer if after knowing all the information, can you answer again if yes, no, not at all times? Makikita natin kung anong nangyari. Be honest. Okay. Okay, after the seminar, I believe that based on the answer of yes, so when it comes to cable and power and data cable, ang ibig sabihin nito, meron tayong nakikitang again A, so na-practice talaga, so the other seems honest, so again we will treat that one 40% not at all times. Sabihin natin 40%. Not at all times. So I think I am done with the presentation. For the wired and cable and wireless communication, I will no longer discuss this. I think time is over. Time na ba?
Yes.
Okay, so I'm done. Kayo na lang carry on mag-view nito sa slides to be shared. Okay, that's all. Thank you.
Okay, thank you very much, Engineer Joel. For your last question, please, fellow IECEPs, we should answer it with yes. Okay? From the discussion of Engineer Joel, that the knowledge he shared, we should answer with A. Now, Engineer Joel, your topic was fantastic. It's provided insight on power cable versus data cable, as well as cable standard specification of the Philippines and for Philippine environment and international standard. You mark it on. It's all there. The information is very clear. Now let's proceed with the Q&A portion. Zoom Master, please flash in the first question of Engineer Joel. Zoom Master, if you are ready, please zoom in. So, Engineer Joel, that's for your next, I think some of your slides are not being presented. Maybe we can arrange for another colloquium, then you can continue what is needed to be shared. Okay, I thought you have a plethora of topics to share to us. Zoom Master, do we have some questions to flash in? Engineer Joel is waiting and eager to answer our question. Okay, now Engineer Joel, question 1. What is earthing, bonding, and grounding? Besides safety aspect, does grounding system will affect the loss of signal in the maximum power transfer? Engineer Joel, question 1 is yours.
Okay. What is earthing, bonding, and grounding? Depende to sa kategorya or level of system level. Meron kasing grounding para sa telecommunication, merong grounding para sa power. Now, ang question dito, what is earthing and bonding? The answer here is to ensure that there is a common returning path at hindi go astray for the other currents. So ang purpose ng earthing and bonding is to ensure the common returning path and mainly for protection. For protection talaga, part of the protection. Yun ang pinaka main reason. And then here, meron pang sinabi loss of signal. Kung ang grounding mo is bagsak, it can also affect the maximum power transfer. Dahil ang circuit mo, kung titingnan mo ang circuito kasi, on the ground is kasali kasi sa path. But by the way, this is to tell you na hindi current carrying capacity ang grounding. Take note, iba ang grounding, iba ang neutral. Yung neutral ang may current carrying capacity. Ang grounding is mainly served for safety purposes. Yan ang pinaka main reason. Another reason is returning path. Meron kasi tayong clean earth at meron tayong normal earth. Kaya this is my answer on that. About the loss of signal, yes.
Okay, go ahead. The loss of signal.
Okay. Anything else? Yun ang masasabi ko. Ulitin ko one main reason why we have grounding. Number one is for the safety of personnel, safety of life and property. Yan ang pinaka main reason. And the other reason is returning path. Returning path yan to the earth.
Okay, thank you very much, Engineer Joel. Zoom Master, we have question number 2. Please flash in. Okay, I will read for you, Engineer Joel, in regards to the lifespan of cable. What is the recommended lifespan of a cable? Please your experience or example.
Actually, magandang question to. I like it. Maraming instances na tingnan na lang natin yung telecommunication ng PLDT. Gaano katagal yung mga kable na pinagkakabit underground or aerial? Ilang years yun, yung sa telephone. As much as possible, we consider that for a lifetime. I agree with one answer. Design for a lifetime. Yan ang, as long na hindi siya hindi siya affected by many factors. Nakikita nyo naman ang factors eh. Kapag hindi na-alter ang mga factors, it can be for a lifetime. But we cannot assure why. Sinabi ko na kanina about the environmental factors. Isa yan ang nakaka-affect sa kable. Environmental factor. As much as possible for a lifetime. But in commercial sense, sa mga negosyante or in business side, we cannot go for a lifetime. I'm aware on that. I'm aware on that na as telecom engineers, as engineers, we want for a lifetime. We want a long lasting, but we have also to follow yung ano ng business. Meron tayong business model to follow. So, mapapansin mo na panay pagbabago, kakatapos lang ng 5G, pumalit agad ng 6G. It's actually wala tayong issue sa system. Ang issue nito, ang relation nito is in terms of business or economics or in terms of demand. Yun ang reason dyan. Dahil for a lifetime sana or is as much as possible for a lifetime dapat.
Okay, thank you very much. So, question number 3, Zoom Master. Okay, question Joel. What is the grounding system of a system which is, I think, is a bare wire? How many feet it is buried in the ground? There's 2 questions in one. What is a system of a system is bare? Maybe this one.
Yeah,
Why?
based on
Yes, go ahead.
okay. Based on the standard, bare is recommended as for the grounding. Bare talaga yan kapag nasa lupa. And also, how many feet it is buried in the ground? Magdepende to sa grounding resistance requirement. Hindi walang specific na height, pero meron yan siya. Like for example, the ground rod is somewhere 10 feet. You have to push the ground rod underground, typically 10 feet. So magdepende to sa system kung may certain standard you have to follow according to the type of system you have. Kaya may mga height yan. May mga height.
Okay, so bare is mandatory for this one grounding system. I think he's talking about the grid grounding. Okay, go ahead. Number 4. What is the required test acceptable for testing a Cat6 cable and a fiber optic cable? Please share your experience with this, Joel.
For the Cat6 testing, nilalahad ko na kanina yung paano ka mag-test ng category 6. Ang una mong titingnan is local standard, kung compliant ba to, i-check mo kung itong brand na ito is with the local standard. Kapag may compliance sa local, ibig sabihin dumaan siya ng test ng local standard. Okay, why we need to check first if it is compliant with the local? Dahil hindi lahat ng kable na dumating sa Pilipinas ay compliant yan. Baka minamarkahan lang na compliant. So, when it is arriving in the Philippines at meron siyang BPS standard, number 1 is pasado siya sa local standard o compliance siya sa local. Kapag compliance siya sa local, dumaan na siya ng testing. Dumaan na siya ng mga test, electrical test, environmental test, mechanical test. Yun ang mga requirement dyan. Number 1 yan. Now, what is the required test acceptable for the testing Cat6? Depende. Insulation test, titingnan mo kung bagsak ba. Actually, nakalahad na doon. Insulation test. Usually, insulation test, yung resistance is around 1 gig pataas. 1 gig. Yan ang mga typical example na insulation test. What else? Cat6, i-check mo yung rate, data rate. You have to test the data rate. Maraming equipment. You have an equipment to do that, to test for the category 6. nakasaad lahat yung mga mga items o mga parameters. What are you going to test? Nandun,
Okay.
nakasaad na kanya. Including the fiber optic.
So you mean is a government entity who's handling this one prior to the market? Agree with this one. Okay. So question number 5, please, Zoom master. Question number 5. What is the treatment for PO cables? Okay, this is Joel. Go ahead.
What is the treatment of for POE cables? As from the beginning, there are 3 categories. We have the data, power, and POE. I mean hybrid cables. So POE is under hybrid cable. So nasasali na rin ang POE cables sa classification ng mga cables. Now, what is the treatment for PO cables? You have to treat like the data and the power. I-treat mo the same. Whatever the requirement of the power, you have to check the we call that one the characteristics. How about for the data? You treat also the same. Ganun ang gagawin mo, individual. I-individualize mo rin ang pag consider, we call that one.
Okay, thank you very much. Zoom master, do we have a question 6? Okay, question 6, General Joel, the question is yours.
What is the lowest impedance for data cable? We are talking about data. Normally, you have to look at for the characteristic impedance. So, ang tanong dito, what is the lowest impedance for data cable? Marami tayong, there are common ZO na cables. We have the 50, 75, we have the 300, we have the 600. These are very common. Now, if your question is, what is the lowest impedance for data cable? Then we look at the characteristic impedance. So, you have to look at the cable characteristic impedance. Yun ang ano mo, yun ang unang mong titingnan, especially for data. Okay?
Okay, I think it will be in the material specification included in the shipment. Okay, question number 6, 7. Sorry. Okay, now we have now at this time we will be awarding the certificate of appreciation. Engineer Joel, thank you for your support on this colloquium. It's a success. Without your topic, this will be part of the success of our colloquium. Now we have to present the certificate of appreciation to present to Engineer Joel Aragon, PECE, PEE, in sincere acknowledgement with this valuable contribution as a resource speaker for the 4th Colloquium on Power and Clean Energy with the topic Power and Data Cables Matter, given on the 12th day of August 2023, signed by the 6 engineers, as you have said, Engineer Enoval of Bulacan, Jackson of Mindoro, Mauna of ERC, Sarcelia for Cavite, Kenko for Manila, and but not the least, for Engineer Mark Philip of the IECEP Power Electronics Society. Engineer Joel, this is for you.
Thank you.
Okay, thank you, Joel. Hope you see you in the next colloquium. Now let's proceed with the awarding of certificate of appreciation to our what we call this one is our chapter collaboration. Now, as you see, certificate of appreciation to IECEP Bulacan chapter. With sincere appreciation with the chapter invaluable contribution in supporting the 4th Colloquium on Power and Clean Energy given on the 12th of August year 23, signed by Engineer Fernandez of Power Electronics, Eliazar of Power as well as the Vice Chair, and Diction for our Secretary. Next, for the IECEP Bulacan chapter for the contribution as the collaborators of this colloquium. Thank you very much. Also for the IECEP Cavite chapter. Thank you also for the full support for this make this wonderful day to have this colloquium. Next, also IECEP KSA-ERC for the collaboration of this today's activity. Next, Manila chapter. Thank you, Manila chapter, for the collaboration effort to make this activity a success. Next, okay, IECEP Mindoro chapter. Okay, thank you for the support, technical support, for all your help on to make this colloquium a success. Next, not the least, let's have the IECEP Cavite student chapter. Thank you very much, my dear students, to be part of this fifth colloquium. Thank you very much. Now let's move on to our announcement. Zoom Master, do we have announcement to be flashed in? Okay, later we will have a Zoom if we have some. Now let's announcement. Yes, do we have some announcement? Please zoom in, or we proceed with the picture taking. Now I would like to request everybody in the Zoom to open your cam to have the picture taking. Okay, Zoom Master, please be ready. And can we have one IECEP so that we will take one IECEP, please? And Zoom Master, let us know if you are already captured all the beautiful faces and handsome of the IECEPs.
And on the count of 3 po, 1, 2, 3, smile. Another
Smile. Second slide.
smile.
Okay, third slides.
And po. Thank you so much.
Only two slides or 3? Okay, we are more or less 141 participants. May I know who are in the student chapter? Can you please type Y if you are from the student chapter? Please, those who hit your keyboard with Y. It's only one. I saw one only. Except Cavite. I think the subject was very interesting for you as a student. So hopefully those topics are also captured in your subjects. So that is very helpful, particularly in the workforce. All of Engineer Joel mentioned on the last topic, it was very helpful. It's like the real scenario. Okay, so the Zoom picture, please turn up the, okay, we will proceed now with the closing remarks. So as we have said, in every story, there always an ending. Now I will call in Engineer Erwin Ilyasar, the VP of Power Electronics, for the closing remark. Engineer Erwin, e-space is yours.
Hello, good afternoon to everyone. And on behalf of the Power Electronics Society, and the EXECOM and the subcommittees and those who help us in executing this event, especially to the expert, Engineer Magaro, Engineer Kedeng, Engineer DB, Engineer Valdez, and Engineer Arjona, and to the collaborating chapters, IECEP Bulacan, Cavite, IECEP KSA-ERC, Manila, and Mindoro. And of course, to our partners, ABB Incorporated, Adamson University, Advanced Energy Incorporated, and Philippine Space Agency. So we'd like to thank for the success of this event. And for other remarks, I would like to invite everyone, especially those practitioners, ECE, and those passionate in the power electronics to help us and volunteer to the journey of our society. So our Chairman MP Fernandez have so many venture to the from his leadership or to the plan, not only to make this colloquium, but also to have a partnership with other stakeholders and like other companies, universities, to pursue our goal in our profession. The society is one of the things that help us to level up our qualification to the level 8 PQF qualification framework of the Philippines. So sa mga expert, so isa sa mga priority na ginagawa rin ng IECEP Power Electronics Society is ang pagbubuo ng Philippine Electronics Code. As of now, we are having a draft for the power electronics in solar PV system. So in this case, it doesn't mean na kami lang ang gumagawa. So we actually are looking all those experts and looking those practitioners to help us para maging maayos yung pagpapublish natin ng electronics code. Kanina, dun sa ating mga questions from the first speaker up to the last, mostly the question is what are the regulation, what are the role of ECE in the practice of the power electronics, etc. So actually, for having a society or a specialization society, ito yung venue natin para sa mga ECE practitioner natin na magkaroon tayo ng involvement sa mga claims natin. So, syempre, available na sa kadalasan yung mga international standards at sa mga regional standards. But we are here in the Philippines to hone our local standards. And one of the goal ng Power Electronics Society is makabuo ng local code wherein ito yung i-adapt natin in our practice. So ito, magagawa lang natin to kapag lahat tayo is involved. Kasi hindi naman siya na nakalagay lang or inadapt natin sa ibang bansa pero iba-iba. So kailangan magkaroon tayo ng isang konkretong electronics code na mai-adapt natin na appropriate para sa Pilipinas. And that's thing na isa sa pinakang malaking bagay na ating kailangan para magawa ito. So muli po, we are calling all the IECEP practitioners, professional na maka-involve po sa binubuo natin power electronics codes with regards to sa ngayon is solar power system. At muli po, in behalf of the Power Electronics Society and all the IECEP National NSS, thank you very much for the fourth colloquium and power and clean energy. Thank you very much at magandang hapon po sa lahat.
Thank you. Thank you very much, Vice Chair. You are the one. Okay, there's something asking for the link. Can we give them at least 5 to 10 minutes to be on the Zoom? Pause, please. Please share once again the link for those people who need to register the link. Remember, the link, evaluation link is very important. Okay, for your e-certificate. As we know, CPD point is very important nowadays. Not only for your what we call that, for not only for your in the PRC requirement, it's also for professional uplifting. It's very important. So at least we can give them 5 minutes, Zoom Master, to have the link and have their registration. Zoom Master, are they required to register in myicep.net? It's also required, right?
Yes, Pradras, they are required to register at myicep.net for the CPD credit. For ECEs, the CPD accreditation will be directly credited to them. And for non-ECEs, they can apply for self-accreditation.
Okay.
If they need certificate, we will be issuing. Thank you.
Yes. Thank you very much. Loud and clear. IECEP, who needs CPD points? Well, before answering this one, you have also to have to register my IECEP. It's still open, right away, Tony? My IECEP.net still open, right? As of the day?
Yes, Bradras, they can still register at myicep.net for their certificate and also the CPD credit.
Okay,
Yeah,
thank
so
you.
please do go to myicep.net and then register to your account, and then so that we can send your certificate and also your CPD points. Thank you.
Yeah, loud and clear. So my IECEP.net is required. Okay, prior to have the e-certificate issue one. So please do so. Go to your IECEP now, as well as the registration link. Okay.
And then
Evaluation.
furthermore, Bradras, I would like to announce that we still opened all the evaluation link until, let's say, Tuesday or next week, so that everyone will have enough time to accomplish the evaluation links and also to register at myisep.net.
Okay, for the evaluation link after this, where they can have the link in our FB page.
Yes, all the certificates will be distributed, Bradras, for all ECEs on myisep.net.
No, for the evaluation after this one, you said it will be at least Tuesday. It will be closed, so they can still access to.
Sorry, Bradras, can you repeat it again?
The evaluation link. It will be closed until Tuesday. Is that correct?
Yes,
Evaluation
Bradras,
link.
yes. For the
So,
evaluation links
after
for
this,
both AM and PM session.
where they can access the link after this.
Sir, down po ba ang ICEP? Mainnet? ICEP portal?
Naka-up na po mga kasama.
Up na po.
Please open your mic, Zoom Master. Admit, so we have still more time to have 5 minutes, so we will close at 12:45 so that they can share the link. Up na po, sir. Okay, naka-up. Open na po yung My IECEP portal. Okay. Open na po. So My IECEP portal is open. Please register together with the link. So 2 things you need to do. Okay, so by the way, IECEP Power Electronics is open for speakership. Is that correct, Brad NP? For the 5th Colloquium? Okay, I encourage all PCE to share your expertise.
Yes, thank you very much, no?